Hello, everyone, and welcome to the first virtual iTech forum. Excuse me. My name is Max Briggs, and I started off my career as an engineer doing several different space nuclear power system activities. But in recent years, I've gone and transitioned to the business side of NASA, where I focused on projects such as strategic partnerships and SBIR. In those roles, I've been trying to figure out how to break down barriers to entry for startup companies and commercialization-focused companies and entrepreneurs to engage with NASA. I'm very excited to start in my new role as the iTech program executive to try to continue a tradition that was originally laid by Kira Blackwell to do just that, to figure out a way for NASA to engage a group of companies that have not traditionally been drawn to government R&D. So what is iTech? iTech is a cooperation between the National Institute of Aerospace and NASA. Our team takes on companies that have both a commercialization focus and a dual use for a possible NASA application. The team consists of several different people with strong ties to the entrepreneurial ecosystem. The programming consists of hands-on mentoring and direct access to several different NASA stakeholders, including people like Center Chief Technologists. The mission of NASA iTech is to provide NASA a way to speed up their innovative processes. The government is not known for being easy to access or being quick in its decision-making. iTech aims to attract companies that are fast-moving, commercialization-focused, and have a possible spin-in use to NASA. We are looking to satisfy goals that NASA has not been funding through projects, allowing those innovations to mature in the private sector before spinning back in to NASA after having received investment from the private market. To this point, NASA iTech has taken on over 800 proposals and over 70 finalists. These finalists have received over 600 million, contributing more broadly to NASA's strategic objectives. So, what does NASA iTech look like? There's two major programs running through it at NASA iTech. One is the Ignite the Night, which are smaller events that feed into our forum events. The original applications there's one winner chosen out of every Ignite the Night. It becomes an automatic finalist for the forum events, such as the one we're having today. Other applicants can apply directly to forums. They are chosen based on their commercialization potential down to a group of 25. That group of 25 is further weeded down to the group of the top 10, that selection being made by NASA Center Chief Technologists. The top 10 then enters into an intensive mentoring program with the NI team and subcontractors in order to develop their commercialization plan, their pitch, and their potential for NASA applications. Today's participants include Amalgamated Vision, Aperionics, Mojo, Neuroflow, Autolith, Orbitless Drives, Skyrora, Tivasol, and 6DOF Space. They've put a lot of really hard work into this point to get to be a finalist. It's a very competitive program and a very intensive mentorship, and I really congratulate all of you for getting it to this point, going through the intense mentorship. It's been a pleasure to work with all of you, and I really wish you guys luck in the coming days of competition. So, typically, a NASA iTech forum is done in person, and that's usually the best way to get good collaboration. However, we are not in an environment right now that allows for in-person events. So we have switched up the format slightly, and to let you guys know what to expect over the next few days, we will have 5 companies presenting today. Those pitches will be done not in a traditional pitch format, but in a video format. There will be five companies going today. Each video will be followed by a direct public Q&A and then an additional private Q&A session that will allow the center chief technologists and the judges to deep dive into the technology. The last 4 companies will go tomorrow in a similar format, and with the selections being made at the conclusion of the programming tomorrow. Now, I would like to give each of the judges for the iTech Forum a chance to introduce themselves.
And so, John Carr, let's start with you.
Great. Good morning, everyone. Yeah, I'm John Carr. I'm the Deputy Center Chief Technologist here at the Marshall Space Flight Center down in Huntsville, Alabama. My background's in power systems, renewable energy, and solar cell development. But more broadly at Marshall, we get into a lot of technologies, but our primary focuses are on advanced propulsion, cryogenic fluid management, additive and advanced manufacturing, and life support systems. So glad to be here and looking forward to a great couple of days. Thanks a lot.
Thank you, John. Let's go with Cheryl.
Hi, my name's Cheryl, and I'm an investor and judge with Finite Capital, and my background's in software engineering and natural language processing.
Thank you, Cheryl. Peter?
Good morning, everyone. Welcome to iTech. My name is Peter Hughes. I'm the Center Chief Technologist for NASA's Goddard Space Flight Center, which is home to the largest collection of scientists and engineers conducting space and Earth science missions and overseeing a number of important technology and mission operations areas, including space, comm and nav, and in-space orbiting and manufacturing. It's called OSAM. Forget the acronym. Anyway, looking forward to engaging today.
Thank you so much, Peter. Werley?
Hi, my name is Werley. I am the founder and CEO of StrangeWorks, a quantum computing company here in Austin, Texas. I'm also a general partner at Ecliptic Capital, an investment fund for early stage companies, and the innovator in residence at the MIT Legatum Center at the Sloan School of Management.
Perfect. Thank you so much. Ben, can you introduce yourself?
For sure. I'm a longtime entrepreneur in Southeast Ohio. I have a product development studio called Nice Mohawk. I'm also an executive in residence for an early stage VC fund, Tech Growth Ohio. And the last, but maybe most apropos, I edit the popular Orbital Index space newsletter, focusing on space startups, space tech, and exploration.
Thank you so much. Harry?
Hello, I'm Harry Partridge. I'm the Chief Technologist at NASA Ames Research Center. NASA Ames is one of the, it is a research center itself, so it's a pretty broad portfolio. Focus areas for for Ames include entry systems. So we design most of the TPS materials that for the return flights, entering atmospheres. Advanced computing and IT systems, so supercomputers, quantum computing, aerosciences, air traffic management, autonomy and robotics, space and earth sciences, and the astrobiology and life sciences, particularly life detection. Thank you very much.
Thank you, Harry. Appreciate that. If we can go with Julian, please.
Hi, everyone. This is Julian Pham. I'm a physician by training, entrepreneur in the healthcare technology and biotech space. I'm the founder and managing partner of Third Culture Capital. We invest in early stage healthcare technologies at the intersection of various disciplines.
Thank you so much. Kurt? You can introduce yourself, please.
Good morning. I just managed to get connected about 5 seconds ago. So I'm jumping in. I think you wanted me to quickly discuss my background. I'm the Deputy Center Chief Technologist at Glenn Research Center. Prior to that, I was the program manager for the STRG program, Space Technology Research Grants. And I spent 28 years as a researcher looking at reacting systems in microgravity, specifically combustion systems, and overlapping that about 10 years developing ISRU technologies. So that's the background I bring to this, and I'm looking forward to all of what follows today. Thank you.
Thank you so much, Kurt. Rick, if you can introduce yourself, please.
Hey, everybody. I'm Rick Stockberger, President and CEO of Bright Energy Innovators. We're the only energy-focused incubator in the state of Ohio. We do a couple things there, mentor early-stage companies through the process of commercialization. We also have a small R&D lab that's focused on energy storage and sensor products, as well as different types of grid and grid edge capabilities. And then beyond that, we also manage the coaching process for APEX, which is an Air Force Research Labs program. And I'm really excited to be a part of this and to be on this team and hear some really new, great and talented innovators move forward. So thank you guys for the process.
Thank you, Rick. Ramona.
Hi, I'm Ramona Travis, the Center Chief Technologist at the Stennis Space Center, located just about an hour northeast of New Orleans. We are the nation's largest rocket engine test complex, possibly in the world. In addition to that, we also do a fair bit of work in autonomous systems for facilities here on Earth, as well now looking into space applications for in-space work and lunar surfaces. My background is in remote sensing technologies and science applications.
Thank you so much, Ramona. Sherman, you can introduce yourself.
Yes. How you doing? My name is Sherman Williams. I am a co-founder and managing partner of the Academy Investor Network. We are an investment fund where with select deals at the seed and Series A level, we syndicate those deals to graduates of the 5 U.S. military service academies. I'm a Naval Academy graduate myself, and I was a military officer for many years. We invest in veteran-led startups as well as civilians with dual-use tech. We pay special attention to national security technologies. I also run the pre-seed program at Scout Ventures, which is a frontier tech, deep tech venture fund.
Thanks so much, Sherman. Jim?
Good morning, everybody. My name is Jim Young. Excited to meet everybody here today and excited about seeing the next couple of days. I'm an investor based out of Omaha, Nebraska. I'm also a partner in M34 Capital that specializes in commercializing scientific research. We have a little bit of a unique model where we consider ourselves co-founders with the projects that we invest into, and we actually help build the company. And we also really try to follow the evidence-based approach in entrepreneurship, but also in investment. So again, good to meet everybody here today, and I'm looking forward to learn more about what you guys have been up to.
Thank you so much. Now, that was all of our judges, but we do have one of our participants in the impact table logged on. Dallas, if you want to introduce yourself real quick.
Yes, this is Dallas Binhoff. I'm honored to be one of the judges or evaluators for this process. I'm the founder of Cislunar Space Development Company. We are developing reusable transportation architecture from low Earth orbit to the moon and all points in between. I retired from Boeing in 2017 as a space architect and program manager for NASA and commercial space opportunities. Glad to be here and looking forward to hearing what you all have to say.
Thank you so much, Dallas. And with that, Max, I'm going to turn it back over to you.
So I hope everybody can see part of the iTech philosophy is to bring lots of very smart people from very diverse backgrounds into the same room across several different fields. We have technologists, we have members of the entrepreneurial ecosystem, we have entrepreneurs themselves, and getting a lot of smart people in the room together can lead to some really successful things, some new ideas, some new opportunities for both the companies, the investors, and the users of the technology here at NASA. And I'm really excited to see what comes out of not just the presentations in the coming days, but also the interactions between those judges and everybody that's participating. I really appreciate all of the judges, all the participants, and all of the companies. Before we get into the actual presentations for the companies, we are going to invite our guest speaker, Rich Godwin, to say a few words. Rich is the founder and president of Space Technology Holdings, LLC, which includes financial management and oversight of their portfolio. He's a lifelong serial entrepreneur in Europe, North America, having founded, built, and exited multiple medium and large companies in various industries, including hospitality, commercial engineering, global supply chain logistics, media, publishing, e-commerce, digital marketing, technology development. He's worked as a business consultant for SpaceX on their nascent Dragon Lab program. He's the CEO of Zero Gravity Solutions, a public company conducting microgravity research on the ISS. He has a lot of experience in both the private markets and space, and he's a perfect speaker to try to let us know how those two things can work together. Rich, thank you for attending, and really appreciate your words.
Thank you very much, Max. Can everyone hear me okay? Because I've got a bit of a lag here, being out in the Midwest here. So thank you so much again for the introduction. I'd actually put together a small little talk this morning, and then I started to watch all the videos. I watched the videos of all the presentations that are going to be putting together over this next couple of days. And I thought, wow, I've never seen such incredible technology as we have in this group. This is by far the best NASA iTech grouping of technologies that I've seen in the 3 years that I've been honored to do the judging with this, and made many friends with my NASA friends and with the NASA iTech team, who I thank greatly for the way they put these together, because they do a great job of this. So I kind of, I thought, okay, there's always questions that entrepreneurs always want to ask of investors. And I thought, okay, let's see if we can look at some of those questions, or at least be able to provide some answers of things that they might not have asked about or thought about. And like I said, then I watched the videos and I thought, wow, my little speech here would be like trying to teach my grandmother to suck eggs. That's an old saying from England about trying to teach people who already know something how to do something. So, Robin, if you could just put up the first slide. What I will do is I'll just put a few kind of questions in here, that this is what investors want. And I know there's some very interesting investors on this call already. I'm one of the venture partners in Starbridge Venture Capital, and we ostensibly started the company in 2017. We're space focused, meaning that we really are looking at dual use technologies, both space derived and or space designed. And so we're looking at things that we can find in the global economy that might be useful in space for NASA, or vice versa. We see something that is being built or designed or created for NASA, and we look at that and go, well, wow, that's got applications down here, and much larger applications than maybe what NASA is thinking about. And so we've been looking very diligently at these. We're just in the middle of Fund 2. We've already deployed to 10 companies in Fund 1. We are, as I said, very space focused, and we've been incredibly impressed with the ideas and what is out there in the commercial space arena. And we do see that there is a sea change in the way that people, investors, Wall Street even, is looking at space. This is a new vista that is opening up. People want to get into space now. There's that groundswell of people who just want to be in space because it's cool and sexy, but there are other people who are very financially minded who are looking at space as, wow, we can actually make money here now, and I agree with that. I think it's a little bit like we were in the mid-90s, when, did you invest in the internet back then? If so, did you invest in Amazon or maybe eBay? Well done. Or did you invest in pets.com or furniture.com? Condolences. What was the difference? Maybe the difference was that you needed to have somebody who understood what the internet meant. And I think we're in the same kind of position now with space. We need to look carefully, or investors need to look carefully at the talent that's out there and to have somebody maybe translate the technical aspects of it, because there are thousands of financial analysts sitting in cubicles right now looking at spreadsheets. There's so many of them. And that is a skill set that is obviously needed. You have to be able to look at financial spreadsheets, but they don't really in any way understand the technical aspects of what you're doing as an entrepreneur, what your business really is. And so we try to make sure that we understand the technical side. And as a result of understanding the technical side, it means that we can come in at an earlier stage, even pre-seed, because we know what goes where and why. And my team has been in and around the space industry for several decades. So basically, I just had some questions here. So you've got a new idea, you create some IP, you built your team, and you want to productize your IP. Now, all you need is capital. Next slide, please, Robin. You think it's the best thing since sliced bread? Oh, go back one. I think you jumped 2. I need to go back to number 2. There we go. Everybody thinks that okay. Everybody thinks that their idea is a $1 billion idea. It's the best thing since sliced bread. Everybody thinks that. And so, okay, maybe not everybody. It's because some of you are already pointing the finger at me. But most people think that their idea is a winner. Otherwise, why would you do it? And you want to make sure that if you commercialize it, which basically that's what it's about. Commercialization means it has to be profitable in order to be sustainable. And so it's very important to be looking at the business aspects of how you can take your product to market to give your investors a return and to be able to allow them an exit. That's incredibly important. Exit, you have to think exit right from day one, even though you might not want to do that. So next slide, please, Robin. So number one, what I look for as an investor, what my team looks for is bring better solutions to existing problems, better than those that already exist. It's really important that we understand what the problem is and to bring that solution to the problem. Many times I get pitched by people who say, oh, we can mine asteroids. Okay, why would you want to do that? And then they explain, and it's like, okay, that's reasonable. But who's your client? Who's your customer? And so I think that it's very important to be able to look at problems that actually exist as opposed to creating a solution that's looking for a problem. So that's really important, I think. So next slide, please, Ryan. This is really important. How does your product make your client or your strategic partner's product better? Many people don't think about this. You get a stakeholder or a strategic partner. I have one in one of my companies now. You start to think, how can what I'm doing make your product better? So that is something that you should really think about if you've got a partner or a major stakeholder, and think about what you can do for their business, not just their investment, but their business. How do you make their business better? Next slide, please, Ron. What's the economic reason for your business model and how do you make money? This is one of these things where you see some people really jumping ahead, and I don't chastise them for this. I don't chastise people for wanting to mine asteroids or wanting to mine the moon. I think those are absolutely going to be incredibly huge industries at some point. But I still have to know what is the economic reasons behind it? I once got asked to run an asteroid mining company. I was there when it was being set up at the very first meeting. And I turned them down, not that I didn't like them or I didn't like what they were doing, but they didn't really have a grasp on how they were going to make money. And it was all down to, well, let's just get lots of investors to give us lots of money and then we'll go and make money. It doesn't work like that. You just end up spending a lot of money and you're not getting to your exit. So that's really important. What's the reasoning for your business model and how you make money? And I know a lot of you already know this, and that's why I said this speech of mine is very much under par for this audience. So next slide, please. Yeah, this is having government as a client is great. Having NASA as a key tenant client or an anchor client, fantastic. But they cannot be your only client. You have to be looking for client 1, 2, 3, 4, 5, 6, 7. It's really important that you consider. And it's like, I always look back to when I build a business, it's like building a pyramid. You have all these big blocks, and the reason that they built the pyramids from the big base upwards to the pointy bits is because that's the way you build a pyramid, and that's the way you build a business. And you don't invert the pyramid. You don't start from a presumption of one block or one assumption or one client and then build the pyramid inverted, because it's going to fail on you. So I always think that I'd rather have 50 small clients than one big one. And so government, fantastic, but you are subject to the whims of Congress as opposed to the whims of commerce. So I think that having government as a client, as I said, is great, but you can't be your only client. So next slide, please, Robert. And this is what my partner, Mike, always says. Question 5, 6, and 7. Who's your client? Who's your client? Oh, no, by the way, who's your client? I can't stress how much that you have to be always looking for more clients for your business right from the start. Don't be complacent in terms of you've got a big client, you've got one, you have to be looking for client number 50, if that's at all possible. So I mean, these are the things that I just wanted to point out. But like I said, after watching the videos, I kind of said, you guys, I think, already know all this. So basically what I just wanted to shift gears here a little bit. And I'm not a NASA employee. I'm not a NASA iTech employee. I've been a judge and honored to be a judge here for 3 years. And I found this to be an incredible forum. But what I'm going to suggest right at this point is I have a story where I call it the Silk Road of space. And it starts with, what can you put on a camel's back and walk it from Beijing to Baghdad and make a profit? It's got to be high value, low volume, low mass. Silken spices, that's what you could get on a camel back in the days of the Silk Road, and get it all the way to Baghdad, and you could make a profit. What those people in those days didn't do is they didn't say, oh, well, if only I had a 3-humped dromedary, I could take more product. Or if my camel had 6 legs, I could take more product. And that's what's been a question in commercial space for so long. It's, oh my gosh, if only launch was cheaper, if only we could get the price of launch down to $10 a kilogram, I could really make some money. You don't have that. Those people back in the camel days would have loved to have seen a big tea clipper windjammer to be able to take tea from China all the way to Europe, but they didn't have those. They had camels. What has transpired over the last couple of decades is that our camels, being our spacecraft and our delivery systems, our logistics, are getting better. They're getting much better, and the prices are starting to get down. Thanks this great partnership between the new commercial providers and NASA. NASA taking the reins and going with things like the COTS program and the Commercial Crew program have been staggeringly efficient, effective, and have really produced results. And I think that NASA has done a fantastic job with these new companies, and I hope that they continue like that. Going on from that, I'm a history buff. So I always look back to the first two English colonies or facilities that they put in the New World. As you can probably tell from my accent, I'm a Brit, but I'm now an American. So, I wanted to become an American mainly because of NASA. But anyway, so they created, there was a Royal Charters to create Roanoke and Jamestown. The Royal Charter didn't pay for those two little villages, those two little startup facilities. They were paid for by private industry, private enterprise, private investors out of the City of London in the coffee shops in those days before they had the stock exchange. And so they were looking for a return on investment. Well, as we all know, Roanoke basically disappeared, and Jamestown was reduced to cannibalism and had a really hard time. And it wasn't until a gentleman by the name of John Rolfe came along and he created something called Orinoco. And I've actually taken the URL Orinoco Space for this purpose. Orinoco was pipeweed. And what he was able to do was take this tobacco and send this back to the old world. It was the first commercial product that actually made a return on investment, and the rest is history. That one product, Orinoco tobacco, turned Jamestown, it was the spark that is now the United States of America. That's how powerful one product can be. And so what I'm looking at now is I'm thinking our new Jamestown is the ISS. It's the International Space Station. That's our little tiny facility on the frontier that is available to us. It's available to us as a commercial, what's the word I'm looking for? It's a facility that's there for us. It's a little fort on the frontier. And we need to take as much advantage as we can. And what I would ask the group of people on this call is that you are obviously some of the smartest people in the world. You've shown that in what you're doing with some of these amazing technologies that you're creating. And I wish you the very best. It's going to be very difficult to judge who's going to be the best, the winner out of this. And it's incredible to see the type of technologies that you are bringing to the forefront. But I would ask a small favor of you. I know that many of you don't have anything called free time or spare time. That's something that I don't really have much of in my life anymore. But in the event that any of you have any free time at all, I would ask you to think about the fact that NASA is looking to commercialize the space station as soon as the next 4 years. We've got about 8 years left. We may have a little longer after that for the space station. But after that, maybe we're going to have the commercial space stations such as Axiom or Bigelow or some of the others. And they will become free flyers that will initially be attached to space station, but then they will detach at some point when the ISS has to be decommissioned. So you guys being the brightest people, some of the brightest people I've seen in the world, I would ask you to think about how do we get to that first Orinoco product from space, that first product that has to be made in space, created in space. I'm working on a couple right now, which are in the bio stem cell area, which I think are the low-hanging fruit for this high-value, low-volume, low-mass. But I would encourage you all not to take away from your day jobs, because I know that that's incredibly important, but to put a few of your brain cells onto this idea of how do we commercialize, how do we extend our sphere of economic influence out to low Earth orbit to get that toehold again so that we can create that first product, that first Orinoco space product from the ISS, and therefore light that spark that opens up the whole solar system to us. So that's my appeal to you all today. I'd like to thank you for listening to me. I do appreciate, Max, for you asking me to speak today. And to the team, thank you very much. I look forward to the next couple of days.
Thank you, Rich. That was a great talk. I really thought it was interesting, your conversation about having the government be a customer and being a very valuable early adopter, potentially maybe less cost sensitive than for an early stage product than some others, but to not rely on the government as your main customer. I think that is NASA has started to realize over the years that we do not have the money to mature all of the technologies that we are going to need through our own R&D spending. So the only way that we can actually really achieve our goals is to be a user of the technology, but not the user of the technology. And therefore, it's really crucial for us to identify companies that have viable business models so that we can be a component of their success, but not the only component of their success, and so that we can go ahead and succeed together. And I think that was a great point. I did want to ask you specifically if you have any thoughts on how, there are government agencies like NASA, but also including the Air Force and several other agencies that are trying to figure out how to best engage dual-use technology and entrepreneurial ecosystems. And I wanted to know if you have any thoughts on some of the initiatives that like NASA iTech or some of the things that AFWorks and the U.S. Air Force and Pitch Days have going on to try to get into that and capitalize on that.
Yeah, that's a good question, Max. Yeah, I would highly encourage anybody who hasn't been talking to the other government agencies. There are so many different programs. I mean, everything from SBIRs all the way through. You can have craters, you can have STTRs, but you can also go in cold and to like somebody like the Air Force. And I'm just about to do that with one of my companies, where they're not asking for a specific technology that I have, but it's a question of, hey, I have something, would you be interested in this? Because I've got a new type of battery, which we've developed, and that company is actually based in Canada, and we approached the Canadian government with it, and the military immediately gave us a contract to develop a backpack system for the infantrymen. And we said, right, we're now going to do this in the United States. It's a little bit more difficult to get through the system in terms of getting your cage number, your SAM number, blah, blah, blah. You've got to get all that done. But once you get that done, you're in the system. And you have to look at the fact that you've got to look at the bulk of the US government and say, well, where are these budgets? And I mean, NASA has a substantial budget, but so does the DOE. So does the National Institute or the National Science Foundation. The DOD has the biggest by far, obviously. And so if you go to the Air Force or AFWorks, yeah, they're very open to talking to technologists. But so is the Army. The Navy, the Marine Corps, they're all there. Obviously, Marine's part of the Navy, but they're all there. And if you have something that, even if it's not listed as something that a technology that they're actually actively looking for, because they had no concept of what you were able to come up with. I mean, some of the technologies here are just, you look at them and go, wow, and the government is not saying, oh, we want this. What is happening is they'll look at some of these things and go, oh my gosh, we can have that? Great. And so I think there is this aspect of unsolicited approach to different government agencies or departments, and that's a really you should make sure that you cross all those boxes to get into the system.
Thank you, Rich. Really a great talk.
Thank you.
Now, I appreciate it. Now we are going to get into the nitty-gritty of our programming here. We are going to start off, Robin, it is 6DOF space, right, as the first? I'm sorry, no, it's Amalgamated Vision, correct?
Correct.
I'm sorry. Yes, so we're going to see our first video of the day. It's nice to be able to see a video format, which is new to our virtual forum, and I hope you guys all enjoy the show from Amalgamated Vision and the Q&A to follow.
Hello. Every day we hear about the coming digital data revolution that will change the way we live. Extended reality and spatial computing will enhance our lives by making information more available and easier to understand. 7 years ago, Google Glass was released. Since then, tech companies have spent billions of dollars in the development of head-mounted display. Today, anyone can buy these products. So let me ask you, how many viewers at a NASA technology conference are watching this presentation wearing head-mounted display? I would be surprised if anyone is wearing smart glasses. So, why is this happening? When it comes right down to it, the single most important factor holding back widespread acceptance is the eyewear itself. Headsets are bulky and ugly. My 21-year-old daughters would not be caught dead wearing one. The resolution is poor, and despite what you've seen in the media, digital data in front of your eyes can be distracting and annoying. My name is Adam Davis. I am a neuroradiologist and the founder of Amalgamated Vision. We are an optical design company dedicated to creating portable personal head-mounted display, and I believe we have found a better solution. 20 years ago, I authored a paper describing the use of 3D stereoscopic imaging to guide medical therapy. It required low-profile, high-resolution display that would allow physicians to work with their hands and interact with their environment as easily and naturally as if they wore no headset at all. Virtual retinal display was identified as the best technology to satisfy these requirements. Using laser MEMS technology, the image is painted directly onto the retina of the eye. There is no display screen. Over the past decade, Amalgamated Vision created an optical engine that provides high resolution, brilliant luminescence, deep color saturation, and a wide field of view. Our compact size enables a look-down form factor that does not obscure the user's normal vision. It is ultra near to eye, it rests comfortably on the face, and it is 3D stereoscopic. Laser light is safe for prolonged use. Like any light source, it simply needs to be applied correctly. Our technology can serve all mobile display platforms. The addition of pass-through video allows for mixed reality. To understand why our technology is so radically different from other eyewear, we need to take a closer look at the optics. Our paradigm depends on the ability to take the light output of a laser projector and squeeze it through the pupil of the eye onto the retina. This is not a trivial task. It has been an obstacle to the use of this technology despite laser light's inherent advantages: high energy efficiency, deep color saturation, and extreme luminescence. AV has developed the technology needed to overcome the two critical problems: a small field of view and a small exit pupil. Let me explain. Some manufacturers using laser light projection rely on a type of optics called a combiner or birdbath configuration. By reflecting the light on a curved surface, it allows the display to be superimposed on the real-world view with good resolution and a wide field of view. This optical solution is particularly prominent in the aerospace applications, but the large size and poor ergonomics for mobile display are obvious. Consequently, nearly all products today use a waveguide solution. Waveguides are complicated, but simply put, they propagate light via total internal reflection and then periodically let the light escape across a wide viewing area. But waveguide physics degrade the resolution of the light source and their materials obscure the real-world view. Most are neither compact nor appropriate for everyday mobility. In see-through augmented reality, the digital display itself distracts from the subject of the viewer's concern. In these two images, we see an anesthesiologist looking out over the surgical field and an EMT leaning over a patient. In both cases, the subject of interest is obscured. Contact lenses for augmented reality have been in development for over a decade, with or without accompanying eyewear. Contact lenslets greatly enhance image quality when coupled with head-mounted display. Standalone contact lenses are complex, requiring an extremely small light source and internal optics to guide the light path. Design limitations include reduced central resolution, field of view, and light efficiency. The earliest companies to try this approach met market resistance to placing a lens on the eye. Content fixed to the eye may be distracting and obscure the real-world view. However, contact lenses represent the ultimate in ergonomics and aesthetics and may be the best form factor for some applications. AV needed to work through these same problems. The earliest AV design shown here resulted in a proof of concept demonstrating the feasibility of virtual retinal display. However, traditional refractive optics were insufficient for the product performance we envisioned. These optics work well to achieve a small 15 to 20 degree field of view, but beyond this the quality rapidly deteriorates, particularly at the margins. At Amalgamated Vision, we found the solution in a pancake lens, allowing us to fold the light path into a compact space. Our smallest optical proof of concept, shown here, fits comfortably on the face, beneath the eye, and out of the way of the user's primary visual field. It produces a 45 by 12.5 degree field of view, the equivalent of 2 smartphones held horizontally side by side about 15 inches from the face, more than adequate for understanding digital text, graphics, or video. AV technology is flexible. We can scale larger if necessary. For virtual reality applications, where complete occlusion of the real-world scene is acceptable, we can achieve an 85 by 45 degree field of view. Many people think a larger field of view provides a better user experience, but for most tasks, people really only use their high acuity central vision, represented in this slide by the yellow circle. This occupies the central 20 degrees of the entire 200 degree by 135 degree field of view. The magnified drawing gives a better perspective. We see the high acuity central region and the AV display below, inconspicuous in the peripheral field. When the person looks down, the display comes into view. AV optical engine performance is superb. The spot diagram and distortion field shown here is too technical for most viewers, but it is instantly understood by optical engineers. Resolution meets the limits of human vision, and it is excellent across the entire field, an unusual achievement for laser display. Chromatic aberration, a rainbow-like distortion of light, is nearly absent. Because our system is on axis, there is no field distortion. Earlier, I spoke of 2 critical problems. We discussed how AV solved the first one, a small field of view. Now let's discuss the second, a small eye box. Also known as an exit pupil, it is the zone where the eye is able to see the image. A larger eye box allows the eye to wander. What makes our design truly unique is an eye box of 8 millimeters, considerably larger than the typical laser projection of 1 to 2 millimeters, and it rivals any waveguide technology. This engineering tour de force solved a problem that many considered to be the unsurmountable obstacle in laser eyewear design. Pancake lens optics and laser beam scanning have been available for decades, but Amalgamated Vision owns the IP the rest of the industry is headed towards, the combination of a relay pancake lens with laser beam scanning in an ultra near to eye position. Furthermore, the fabrication methods and laser beam scanning products needed to build our light engine have been in use for a generation and are readily available and dependable. The use cases for this technology are endless. There is immediate applicability to the aerospace industry. The NASA Artemis project, Boots on the Moon in 2024, is looking for technologies that can satisfy their need for hands-free, high-quality informatics display. Our technology, small enough to easily fit inside the helmet of an astronaut or a pilot, offers a solution for just-in-time information that keeps the wearer connected to their environment. In theory, AV optical technology will function under extreme conditions and without gravity. It is light, moves precisely with the head, and it does not touch the eye. Closer to Earth, engineers, mechanics, and support personnel can benefit from hands-free data that does not obscure their vision, allowing them to work efficiently while retaining situational awareness. Corrective lenses or safety glass can be easily attached to the superior surface of the eyewear frame. The aerospace industry is just one potential customer. Healthcare needs a high-quality and inexpensive method to deliver hands-free data. Obscuring the vision of healthcare providers is simply not an option. Surgeons, interventionalists, nurses, emergency technicians all need to move freely, work with their hands, and reference patient data whether it is medical imaging, vital signs, or patient history. Stereoscopic 3D information enhances the understanding of complex anatomy. Telemedicine for either expert guidance or patient contact is rapidly becoming routine practice in global healthcare. In addition, our eyewear can be easily adapted to assist visually impaired people thanks to the unique properties of laser light, intense luminescence, narrow beam, and always in focus. In just 8 months, COVID changed the habits of the entire planet. Portable digital information will continue to become more essential as people adopt new remote work practices and a more mobile lifestyle. For spatial computing to become truly mainstream for both consumers and enterprise, it is necessary to have eyewear that everyone will embrace and enjoy. The largest companies in the communications and information industries are betting their future on 5G and increasing use of digital data. There are currently 3.5 billion smartphones in the world. Every one of them represents a potential customer. The potential sales within the combined extended reality market is huge. Analysts estimating gross revenues to reach $42 to $56 billion within 5 years. The go-to market strategy is simple: AV inside. Selling light engines to power other manufacturers' head-mounted display, an OEM arrangement, or licensing our core technology are the most likely scenarios. The first target industries are price-tolerant, data-driven, and display-dependent: aerospace, defense, healthcare, enterprise. As manufacturing costs decrease, the AV light engine will power the eyewear that supplements or replaces the consumer cell phone. At this time, I would like to introduce our team. Dave Kessler, a Kodak Distinguished Scientist, is globally recognized as one of the foremost optical engineers for head-mounted display. Alex Tokman, the former CEO of Microvision, a publicly traded laser MEMS company, is an Allen Institute Fellow. Randy Sprague was the former chief engineer at Microvision and the former CTO of Innovega, an augmented reality contact lens company. I am a former associate professor of radiology and director of the 3D Imaging Lab at NYU Langone Medical Center. I currently lead product development for Olea Medical, a medical imaging software company. All AV personnel have experience in the world's leading technology companies. Our proof of concept, the light engine shown to you today, is project ready and can be built within 9 months. To date, we have raised $326,000 US. We are seeking $2.2 million to take us through the next phase before building a commercial prototype. Our non-obstructive, look-down, laser-based virtual retinal display is radically different from all other technologies on the market today. It has the potential to make everyday spatial computing a reality. The cultural and financial impact will be unprecedented. Amalgamated Vision is the catalyst that can make this happen right now. And if it is not yet readily apparent, it is our dream at Amalgamated Vision to put our eyewear on a NASA astronaut. Thank you very much.
All right, so Harry, let's go with you. Do you want to start off the questions, please?
Yeah, I'd be glad to. Let me just turn on my video. Sorry, I wasn't expecting to be first there. Anyway, very nice. Can you say something about the power? Is it all contained in the glasses that you're wearing?
Yes, the computer chips, the necessary connections via Bluetooth or whatever is used, battery power would sit behind the head. The lasers themselves would also sit behind the head. That's where the laser diodes would be. They would be carried to the front of the face where the laser MEMS sits by a fiber optic device. That way we can put all of the heavier components in the and heat generating components in the back, and in the front of the eye, just simply put the laser MEMS and the optics. Dr. Partridge, I can't hear you.
Harry, you're muted.
power intensive is it, and will it run all day?
Well, that's a good question. It hasn't been built yet, so I can't tell you whether it runs all day. The power requirements, there are two. One are the laser diodes. They're extraordinarily energy efficient, more so than a typical LED that you would see in a smartphone. The laser MEMS and circuitry, just like a cell phone, also carries a certain power load as well. The requirements for a laser MEMS display and the ASICs required would be no greater than that of a cell phone. So I could imagine that the battery could be created that would keep this running all day long.
And the last question I have is, can you put this in a, integrate this with glasses? So I wear glasses, and would I have to be below my glasses, or can I integrate it into my form factor of my glasses?
So the first generation, which was shown in the video that we just saw, which is of course a concept rendering, it is to scale, and all of our optomechanics fit within the structure that you saw. So it is a realistic scale model. However, the first version that we would imagine would have corrective lenses built along the top of the glasses. The glasses lie below the eyes, securely beneath the inferior orbital rim, securely on the cheekbone, the maxilla, and that's where it is stabilized by the nasion, the maxilla, and of course the zygoma goes over the ears. So you would imagine that since it sits below, you could put corrective lenses above that. You could just simply snap it in depending upon what your corrective vision requires. However, what you're looking at is also a device that has absolutely no fabrication scaling performed to it. And I would imagine with the magic of scaling and fabrication that's done in the industry today, we could get that size factor down smaller so that perhaps it could sit like a band even lower down and allow glasses.
Thank you very much.
This is Cheryl. Do you see yourself as a hardware company, or are you planning to have like an app store and a whole kind of suite of software and deliverable packages for these glasses in your business model?
We are an optical design company, and we provide solutions for head-mounted display. We would like to build a proof of concept proving that our optical design and our paradigm truly works. At that point, I think we would embed our technology. Maybe perhaps we would build the hardware ourselves and then sell it to a secondary user, or we would sell the IP or license the IP to a larger manufacturer or a strategic partner. It's a difficult question because it depends what you consider eyewear to be. If eyewear is a simple display that works by Bluetooth from your phone or some primary source, that is a much simpler construct than if you, let's say, wanted to have accelerometers and gyroscopes and video and sensors and all sorts of things associated with the glasses. That requires an ecosystem. That requires the software, the hardware, really quite a large system to put that together. Amalgamated Vision is certainly not at that point right now. Perhaps one day we would be, but at the moment, our go-to-market strategy is as an OEM or to license our IP.
Thank you. Perfect.
By the way, my team is here. Randy Sprague, systems engineer, Alex Stokeman, business advisor, Dave Kessler, optical engineer, Paula Katkin, business development. Guys, please jump in if I misspeak or you can answer the question better than I can.
Yeah, actually, Adam, I was just going to add to what you just said that in terms of requiring a large ecosystem, that can be mitigated by the fact that there are a number of niche markets, such as surgery, or for example, where you can focus the application more, and you don't have to solve all the world's problems at once. You can start with niche markets and move up from there. So it's a smaller task to handle.
So this is Werley. So I've got a couple questions for you, Adam. So first of all, tell me a little bit about the raise and the use of proceeds. The use of proceeds of this raise is for the prototype that you mentioned?
Yes. we're looking to move through the next phase, and that has several components to it. First and foremost, we'd like to build the proof of concept. We have already identified a optical company, optical design company that can do this build. They actually are a laser MEMS research and development company, and they would partner with an optical design company that would produce the optics that we need. So that's the first component. The second component is that we need to continue our R&D. We have several ideas for improving this technology, several ideas for how to minimize it, several ideas for how to expand it. We need, of course, the time and money for our engineers to work on that. The third is that we have organizational costs, of course, and we need to take care of those. We also need to defend our IP. Our IP was distributed. We have already been granted USPTO for the first 2 of our 3 patents, including the patent on the form factor of having a relay lens using lasers close to the eye. So we've actually patented that form factor. But we want to expand on that and defend our patents.
Right, but that's a utility patent?
Yes.
Design patent.
Yes, those are 2 published patents. Actually, we just received the second one in
The one on the form factor is a design patent or a utility patent?
It is a utility patent.
Okay. All right. So last question, I'll pass it on to the other judges. When you think about, investing in a startup, traditionally, I'm talking as an entrepreneur, but venture capitalists usually look at a couple of things. So, what I'm hearing is like you're never going to get enough money to defend the patents, right? Like just bluntly, that's unfortunately a nightmare of a system. So
thank you for that.
I have a company that I'm working with that has $200 million in funding, and they're probably going to go out of business because of patent infringement. They won't even come near it. They'll be in court for the next 20 years. The patent won't even be good. But on the prototype, can you give us an idea of the cogs, or the bomb, what a bomb looks like on that? Like, what does that look like from a engineering perspective as far as getting the components, and from a financial perspective, like to build the prototype? Is this a $500 prototype or a $5 million prototype? Like, give us a little idea of how that is going to be implemented, what that cogs and what the bombs look like on something like that.
The actual prototype itself, separate from the remainder of the costs, would probably be in the range of $350 to $500K to build that out, depending upon how easily it goes. This is a custom one-off product, and as you could imagine, doing it for the first time is very costly. It could always be manufactured to scale cheaply, but the first time. The engineering project has been laid out in schematics. I can't remember the name of that, Randy, if you'd like to jump in, or Dave, but
everything's taped out on that, Randy?
Absolutely.
And we also have a few other judges that want to ask some questions during the allotted time.
Just to answer that quickly, in the presentation, there was a slide that actually gave the 9-month, week-by-week project plan for building the proof of concept. I can tell you that the day we are funded is the day we can start building that proof of concept.
This is Alex. Can I answer? Can I provide some answers? Okay, so two questions. Big tech appears to be very interested in this design, but they want to see a prototype. So this is the importance of this phase, number one. In terms of COGS, it's going to be much more cost effective than anything you've seen so far in the market, primarily because the most expensive components like lasers and MEMS and electronics are used for high volume consumer electronic applications. Therefore, they will be reused, and the cost would be we expect it to be sub several $100s. So it's not going to be the the behemoth that you see from Microsoft or Google Glass, which costs over $1,000. We want to make it basically consumer price.
Thank you. John Carr, you had a question?
Yeah, hey, John Carr from Marshall here. A couple of quick questions. Will it have satellite or Wi-Fi connection, or how do you download, the augmented reality, the data to drive the applications?
We are, well, our current easiest and minimum viable product is a display. It is the equivalent of having a screen that sits on your face and provides a 45 by 12.5 degree field of view. So the connection can be hardwire. You could always have that, let's say, if you were putting it in a space helmet, you could just have the hardwire connection to a box in the helmet. But something as simple as Bluetooth or a Wi-Fi protocol could be used to transmit information between the glasses and whatever your source information is.
Oh, okay, great. So it could be cell phone, could be anything. And then how are the glasses controlled? How do you turn it on and off? How will you, switch between the data feed, etc.?
So that's, does anybody want to take, I'm happy to answer that, but unless anybody else would like to take that question. Okay. The control of the glasses has not been decided. There are numerous companies that have ring and wrist and hand implements that can be used to control devices remotely. Most likely that is something that we would use. Or of course you could also use voice command. The control of the glasses would, to some degree, be on the source image that you had. As you scroll, you might ask to scroll. The other thing you could do is, there's a very simple technique for turning it on, turning it off, or tracking your eyes, and you could use an infrared eye tracking. You could see your eyes look down, turn it on. If your eyes are moving, it could scroll for you automatically. All of those are possibilities.
Yeah, I like it. One last quick question. So you mentioned your daughters wouldn't be caught dead wearing Google Glass or anything else. What do they think about this design? Does it meet their fashion standards to be pervasive into the consumer world?
This design had a 19-year-old focus group, all of my daughter's friends sitting around a table. And when they looked at it, one of them said, "That's sick." And I knew that that was the design. We actually did not pick that design originally. We deferred to the judgment of a 19-year-old.
Thank you very much.
Okay, and we have time for one more question. Peter, I think you had one. Peter, you're muted.
My question has been asked, but actually one thing I'd like to ask is, do we know if the eye changes for the user? For instance, when astronauts in space, we know the eyeball changes in size. Does that affect anything for the operation, or does this automatically adjust?
The focus would stay exactly the same. Dave, Randy, please jump in, but the focus would not need to change with the dilatation of the pupil. The beauty is that if their pupils are dilated because of dark, the exit pupil from the output is wide enough that it would cover a large pupil, a 6 millimeter pupil, as opposed to a bright sun pupil, which would be 2 millimeters. So that's not really an issue for the optical display.
Thank you.
All right, and with that, I think we're going to move to the next presenter. Max, do you want to introduce?
Thank you, everyone. Thank you very much.
Yeah, thank you. Great discussion on that, and great job, Adam. Appreciate it. There'll be more discussion to follow on the impact tables, but right now we're going to go to 6DOF space.
When Mindy Alexander's now 3-year-old daughter, Eliana, kept getting sick, she and her husband, John, were at a loss.
When Eliana was 2, she had 4 strep infections in just over 6 months. After the last round of antibiotics, she started.
Hi, I'm Daniel.
There's nothing like being on stage, having great eye contact with you, the audience, maybe seeing if I got the attention of the judges, and of course, comparing notes with the other teams presenting. But we're going to have to do without that today. The good news is that I'm going to be able to show you more members of our team and more technology than I could possibly bring onto stage with me. I'm going to talk about tracking, and because we're here at NASA, let me explain what I mean by tracking, using the example of spacecraft docking. It's simply that the docking craft must know exactly where it is in order to pilot safely into position. It needs to track its position relative to the craft it is docking with. NASA astronaut Mike Foale was aboard the Russian Mir space station in 1997 when a manual docking procedure of a Progress M34 supply craft went badly wrong. In the resulting collision, Mir was punctured and half its solar cells damaged. Thankfully, no lives were lost. But one thing that the collision made clear was that, whether it's a human or a machine at the controls, accurate and fast tracking data is the key to safe, reliable and repeatable positioning. You might not realize it, but today optical tracking is pervasive in modern life, from the simple sensor that lets your phone know when it's next to your ear, to the LiDAR systems keeping self-driving cars on the road. Modern devices need to be deeply aware of their relationship to the world around them. A little over 3 years ago, we realized that the design of these tracking systems hadn't evolved in years, with many of them based around camera assemblies designed for a totally different purpose. It seemed that people were just shrugging their shoulders and making do with small, incremental improvements. Driven by the belief that we could create a cheaper and way faster solution, we founded Sixth Space. At Sixth Space, we combine optics, algorithms, and electronics into a board that, when installed into a customer product, provides precise, ultra-fast sixth-off tracking using existing facility lights or low-cost beacons as reference points. We're a socially distanced core team of 10, bringing decades of experience that spans from optic lens design all the way to 3D PC visuals. We are based in Jerusalem, Israel, which brings us all the benefits of being part of the startup nation and adds just a little touch of purpose and vision. Even though the company is still young, we've already been part of 2 leading consumer electronics company accelerators, part of 5 international trade delegations, and exhibited twice at CES as part of the official Israel Pavilion. We have consistently received development funding grants. We also give back to the community in multiple ways, with everything from allocating part of the company to charity, through technology development for the country's leading children's rehabilitation hospital, to welcoming missions from around the world. Why did we think the industry was ready for a shake-up? Well, 1 year earlier, Valve Corporation, a leading US game developer, and HTC, a Taiwanese consumer electronics company, released the Vive VR headset, with a revolutionary tracking system that, although expensive and slow, blew everyone away with its simplicity and effectiveness. This system was so revolutionary that the Vive tracker has now been adopted for all kinds of industrial applications. For example, to record the precise camera position used to take engineering photographs.
Hi, I'm Mark Goldfarb, and I am the CEO of Sixth Space. Our tracking and positioning system is indeed unique. We expect the largest market for this technology to be consumer devices such as AR headsets. But until then, we are working hand in hand with major multinationals who have lost faith in what's currently on the market and have come to us for a custom solution that meets their needs. We make sub-assemblies that allow devices to know their position relative to fixed or moving targets. This sub-assembly goes into products across multiple industries to give these products low-latency, sixth-off tracking capabilities. The market is already telling us where to focus, and 3 areas in particular, all industrial, are really buzzing. So let me tell you about moving object tracking. Did you know that 250,000 forklift trucks are sold every year? And that is in the US alone. Apart from having a driver, these are basically dumb devices that move around factories and warehouses all day, but keep no record of where they were or what they did. Our modified iRobot knows where it is simply by observing the room lights above it. We can bring this capacity to forklifts with minimal or no need to retrofit beacons into the warehouse. Augmented reality is coming in a big way, and I'm not referring to hobbyists or enthusiasts. We've seen some of the biggest players embrace augmented reality, including the US military. Industry wants to move beyond requiring technicians and engineers to constantly switch away from what they're working on. With AR, They get to see one unified world, real and virtual together. Many people focus on the display part of AR, but the tracking is no less important. Without knowing where the viewer's head is, it's impossible to overlay virtual objects realistically. With the fast, accurate tracking that we offer, the virtual objects blend seamlessly into the real world. Now, the drone applications really surprised us, and some of these are very similar to the spaceship docking case that Daniel opened with. When drones need accuracy, they use cameras and work optically, but cameras are slow, prone to blur, and require intensive processing. With our optical tracking system, drones can keep the accuracy they need, yet get updates hundreds of times per second, even while moving. We are already engaged with 2 different drone platform developers who need just that capability. We have had serious interest from all these markets. Each one of these boxes represent a multi-billion-dollar industry. We have chosen to focus on industrial use cases, which needs wide open space tracking. This gives us beachheads into the entertainment providers, warehouse, and drone fields. We have paying customers already in these market segments, ranging from a few $1,000s for an evaluation kit to hundreds of thousands of dollars building specialized modified systems for their customers' specific applications. To date, we've raised $4.5 million, roughly half of that through government grants, with most of the rest coming from professional investors. We are already seeing around half our expenses covered by customer revenue. Given that we haven't yet even started gaining economies of scale, we are confident that we will break even and then reach profit before 2022.
Did you know that NASA has already sent 2 Astra B drones to help out at the International Space Station? They mainly use cameras to work out where they are. Pictures are available only once per second and have to be sent to a laptop for analysis. So that's already one place we can really help. And here on Earth, NASA is playing an important role, with SBIR and STTRs focused on challenges such as avoiding drone collisions. In fact, there are so many places in NASA where positioning is critical, or where you've got one object moving relative to another. For example, docking a supply craft to the space station, or making a perfect landing at a remote observation site. But there are also the industrial type use cases, such as checking the position of an articulated arm, or providing an augmented reality schematic overlay during complex maintenance operations. There's even just keeping track of inventory. With its high speed yet low power and low bandwidth, our system can do things that camera-based designs cannot.
Hi, I'm Cloney Lieberman, Vice President of Research and Development at 6 Space and one of the founders. I've been developing unique optical solutions all my life with products such as the virtual keyboard and the world's first commercial near-field scanning optical microscope. Let's think about a 2D camera for a while, and let's imagine that we're looking at a couple of bright objects, maybe light bulbs, and you turn the exposure way down. You'll see 2 small groups of pixels lit up on your camera image, the yellow spots, and the rest is dark. Now, imagine you have some way of summing all the pixels in each row and also summing all the pixels in each column. You'd end up with the X and Y pixel vectors shown. That's basically the same information, but with a fraction of the pixels, typically a couple of thousand pixels instead of a couple of million. And that's exactly what we do. We compress the image from 2 dimensions into 1 dimension using our patented wide-angle optical compression lens. This is a single element, low-cost injection molded lens that, because of its unique design, offers better performance than you get from a traditional 3-element glass fisheye lens. Our lens design is currently optimized for use with off-the-shelf linear sensors, but the optics can scale right down to work with the tiniest sensors you can imagine. This is what our first-generation sensor boards look like. It holds 3 optical assemblies and the control electronics. It's passed rigorous military-level testing for vibration and impact resistance, and now we are prototyping a 2nd-generation design with improved performance and flexibility. I'm going to hand you over now to my team to tell you a little bit about their work.
Hi, I'm Nava. Even the simplest sensor applies some kind of algorithm. For applications that need more capable sensors, maybe better speed or a little more accuracy, you very quickly end up with algorithms that have to deal with high bandwidth data resulting in heavy processing loads.
And I am Mori. I developed the algorithm that first handled the data arriving from the optical sensor in our design. Due to the optical compression lens, we avoid adding significant bandwidth as we take the system toward higher performance. In fact, the raw data produced by our sensor fits easily in a standard USB 2 connection, and even when running at 1,000 frames per second.
Hi, I'm Abigail. No two tracking situations are exactly the same. For example, there are a surprising number of applications where both the object and the target are moving. Normally, we also take data from a MEMS gyroscope to give us additional tracking stability, but in these cases, we have to do pure optical tracking without a MEMS. I create additional functional modules that enable our tracker to adapt to challenging customer situations like these.
I'm Gilad, and I lead algo development. Calibration is a really important topic for any tracking system, because no matter how accurate your manufacturing process is, every single device behaves a little differently. We spent almost 2 years creating and developing this optimal lens design. It's a unique 120 degree by 120 degree optical compression lens. We have spent a further year developing a robust calibration framework for it. In common camera lenses, the angular resolution fluctuates over the field of view. In our lens, the angular resolution stays constant, so we can get the same accuracy whether a reference point is right in front of us or off to the side.
I'm Shlomo. Well, you've heard all about the optics and the algorithm, but there's more than that to creating a tracking subassembly. As you've heard, the hardware now in its second generation runs the electronics of optic sensors and delivers the data to the host system. Our Telegraph 2 program allows you to see what the sensors see before the algorithm starts processing it into tracking data. 2 of the sensors are horizontally sensitive. You can see those in the red and blue traces. And 1 is vertically sensitive. You can see that in the green trace. As the system gets closer to the lights or further away, or as it tilts or rotates, unique arrangement of these 9 peaks changes. So we know that the sensor is moving. Then over to Algo to tell us where.
I'm Anton, and like Shlomo, I work on the embedded and visualization side of things. Visualization is our way of showing the live sticks of information in a way that is suitable for the end user application. We wanted to demonstrate just how effective our algorithm can be, even when running on very limited compute resources. So we took an off-the-shelf $35 Raspberry Pi and used it together with one of our sensors to provide real-time accurate positional tracking updates. Our algo ran on a single thread of the Pi with no fancy GPU or dedicated image processing hardware. This could be on a drone or a forklift, a worker hard hat, or built into the surgical device. We make sure to deliver software that fits into the customer's application framework.
It's amazing that despite having customers from such a wide range of applications, we hear the same feedback over and over again. We hear that they have been working on their product for years, with some of their smartest people working on tracking integration. But that the only way they can get the system to perform as they want is to connect it to a high-end tracking device that is too big, bulky, and expensive for their end product. As soon as they understand how our fundamentally different approach works, they are sold.
Our basic research is behind us, funded by development grants and insightful investors. Our algorithms are up and running. We are now going to market.
I hope that next time we meet, it will be in person, and that you won't have to just take my word for it, because our tracker will be in customer products that you can try for yourselves. So it's time to wrap up. The 6th Space Tracker is low cost, but also low bandwidth, low power, and not compute intensive. It's rugged and reliable, and free of privacy concerns. It delivers full 6DoF at up to 1,000 frames per second, with end-to-end latencies, algorithm included, as low as 3 milliseconds. And it's available now for customer evaluation and as part of a customized integration to meet their system needs. Thank you for being with us today.
Question about the funding you mentioned. You said that half of it, or approximately 4 million, half of it's from grants. Can you give us a breakdown of grants versus the investors? And maybe tell us a little bit about who the investors are and what the terms were that you raised that money on?
Sure. This is Mark. I'm the CEO. The government grants, Israel has something called the Israel Innovation Authority, and we received 3 grants over 3 years. that money is a grant, but they get a royalty of future sales. In terms of investors, most of our investors have been private investors. There are two key angel investors that can't come in. And there's one venture fund that came in from Israel, and also one of the leading headset manufacturers from Taiwan put some money in as well.
So Mark, a quick question, because I want to make sure that all the other judges get time. So is Yoshi Vardy invested in your company?
Which company?
Is Yoshi Vardy invested in your company?
I missed the word that you said, sorry.
Yoshi Vardy, is he invested?
No, he's not.
Okay, just curious. And so the next question is about your patents. So you have the wide field optical module sensor, which is issued in plenty of coverage. Do you know what the status on your indoor positioning patent, which you showed in the video, is with the little robot that you were talking about for the warehouses? And then also the same thing on the asymmetric content protection for the large data streams. And maybe you could tell me a little bit more on what you're protecting with that second patent.
Sure, I'm going to hand that over to Cloney.
Sure. The patents that we have issued to date relate to the optics themselves, to the compression. We have some pending applications in the U.S. describing the overall application, but none of those have issued. One of them issued, but the very narrow use case. So we've actually accepted that, and then we filed a continuation to continue to try to get the broad use case applications. The asymmetric content that you discussed was a side topic that's not really the core focus of our company, and we're not pursuing that technology at the moment.
Okay, that's why I was curious. Thank you so much. All right, other judge.
Thank you. Ramona?
I want to ask about, you mentioned you're free of privacy concerns. Are you able to prevent hacking? Hacking could be really dangerous for some of your activities. So please explain that a little bit more.
I will hand that over to our CTO, Daniel.
Okay. We're not really addressing, if you like, the systems aspect of how do we ensure that nobody breaks into the system and can get the data out. There's, I've actually worked in security before. There's a lot that can be done. What we're saying is there is no image formed in our system. At no point do we have a 2D image of what's in front of us, because by the time the light rays have come through our lens, all that's left is a single optical signature. And you're going to have a hard time taking that optical signature and putting it back into a 2D picture. It's just been squashed down. If you imagine your old TV set, when you turned it off, the whole picture went down to a single line. There's nothing really to see except the data we need for positioning.
I'll follow up more later.
Okay.
Great, thank you, Ramona. I wanted to reiterate that format of a quick question from the judges, a quick answer, and a follow-up in the impact table.
Does the performance degrade in cases of, pollution or smoke?
Cloney, why don't you answer that because you did the testing?
Occlusion would degrade performance if there was no line of sight to the beacons. We've done some testing for one of our customers in a smoke environment, and there's a negligible impact on the signal. If there were a thick smoke that you couldn't see, then yes, but as long as you can view the light, whether it's an IR beacon or a room light, the system can track it.
Thank you.
This has been a quick follow-up on that. What is your distance that you can detect a beacon at or use a beacon? Is it short range, long range? What does it look like?
It's a fairly short range tracking, primarily for indoor applications, up to 10 meters. The distance is usually limited. It's a question of the brightness of your light source, your beacon, but the resolution and the accuracy of your tracking will go down the further you are from your light sources. So we're primarily focusing on short range, that's in the orders of meters, to medium range in the tens of meters distance.
Sherman, do you have a question?
Yes, my name is Sherman Williams. My question is, with respect to your light algo, not necessarily, obviously not the infrared algo, how does the algorithm perform in a low light or even a no light environment? And then for some of these facilities, again, eliminating the IR sensor, just focus on light. Do you have to do a walkthrough of a facility ahead of time in order to map it out so that that algorithm works best?
Daniel, you want to take that one?
Yeah, so starting with the first question, which is no light. If we're in a situation where there are absolutely no light sources, then as a light center, we don't have a reference. But we have a few applications where people have said we want no visible light, for example, in a theater. So in that case, we're using infrared. We can have something that is completely invisible to the people in the room, and we can function very well. You mentioned about walking through an environment. So you'll actually find on our website an example where we walked into basically a small supermarket with our sensor mounted on a trolley. And as we pushed the trolley down the aisle, we were mapping out the lights in the ceiling above us and basically doing SLAM, building a map as we went, and then operating from that. Most use cases actually, though, they're not interested in SLAM when you build a map from scratch, because there are interesting things that they want to have in there. For example, they want to know where particular machines are. So from there, we would use either building information system, our own surveying system, or some external surveying system to tell us where the lights or the beacons were. And then we can give the customer back the position in whatever system frame of reference they want.
Do you have a time per square foot in order to do that?
It's minutes. It's minutes per site. It's basically walking through it, capturing it, and making sure that the system is locked.
So what are the physical characteristics of the installed product, and how much power does it draw?
Daniel, why don't you continue with that then?
Okay, so our current product that you saw in the video is basically designed to be installed into a virtual reality headset. We've had lots of backwards and forwards as to the preferred form factor. As we said in the video, it can go as small as you want. There's nothing fundamentally that restricts us to the size. In terms of power, our current board runs at about 1 watt. We made no real effort to get that down because we expect the thing to go to an ASIC in the medium to long term. The one interesting data point to take away is we were talking to some big players in the field. The fundamental image sensing devices that we're using are probably going to use about 1/3 of the power of any camera-based system. So fundamentally, we can get down to 1/3 of the power.
At the end of your presentation, the person had a box under his arm. I assume that was the product, so obviously that was wrong.
No, that is actually just a development kit that we send out to customers that have bought it. Inside there is the actual sensor board. I don't know if you can see it, but I'm holding one up right now. That's our actual board. It was in the video as well.
Right.
So.
I'll jump in one more thing on power. You saw the bouncing on the spring sensor. We ran that on CES this year. That entire system that you saw ran a whole day on a single charger battery pack.
Peter, do you have a question?
No question. Can you say something about the number of beacons that you need and their distribution in order to get accurate positioning?
Sure, Cloney?
Sure. Ideally, you would want to have 3 beacons in your field of view at any one time to do an absolute optical localization. Our sensor has a field of view of 120 degrees by 120 degrees. So as long as you have those 3 beacons within your field of view, you can track. I said you can localize. Once you know where you are, you can actually continue to track off a single beacon, because the system does have an IMU in it, and it does enable you to track, at least for short term. As long as there's a single light source or beacon in your field of view, you can maintain your tracking.
And can you say something about how you would perform in a place where the lighting changes arbitrarily? So, for example, in your docking case, if it's rotating, the light will dim and brighten as it goes around. Is that going to cause problems?
No, that shouldn't be much of a problem. When we're using our own pre-installed beacons, We actually have the ability to modulate them because our sensor operates so quickly. So each beacon can put out its own unique code. And then the system always knows not just where the beacon is, but which beacon it's looking at. And it can track that as well. So if one rotates out of field of view, another one comes in, you would be able to identify them and know what you're looking at and who you're tracking.
Thank you.
Are there any other questions? All right, Max.
Yes, well, I thought that was very interesting discussion, and there's probably I know we're trying to keep time tight for all questions, so I'm sure there's still going to be a lot of follow-up questions on the impact tables. I hope you guys are able to deep dive when it comes time for that. We have reached time for our first break, so we are right on time for that. So thank you all for sticking to time, and we will be back at 10:45. Thank you all. Hello and welcome back, everybody. I hope you enjoyed the early morning programming for the NASA iTech Forum. We are going to continue on with our next innovator, Crystal Eisenhower for Apiriomics.
When Mindy Alexander's now 3-year-old daughter, Eliana, kept getting sick, she and her husband, John, were at a loss.
When Eliana was 2, she had 4 strep infections in just over 6 months. After the last round of antibiotics, she started exhibiting UTI pains.
And her pain continued for months after, yet doctors couldn't give them a diagnosis.
We ended up going to our pediatrician and urgent care for about 6 or 7 visits, and everything was coming back normal and clear.
Desperate, Mindy, like most parents, turned to the internet and found Virginia-based Apiriomics, a biotechnology company that says they can help solve medical mysteries.
We were very, very frustrated, upset, and just looking for answers.
Apiriomics CEO, Dr. Crystal Eisenhower, helped start the company in 2014 with one goal: to help doctors and chronically ill patients figure out what's making them sick.
We aim to change everything about how infections are identified. We know that there are millions of people living with chronic infections, and the current system can't identify those. The tests simply don't exist. Instead of looking for one thing at a time, we're looking for everything that's known at a time. So we screen every sample for over 37,000 possibilities.
The company insists they don't diagnose or treat patients directly. Rather, with Eliana's test results, her own doctors were able to treat her specific strain of infection. And within a month, her symptoms were completely gone.
I assumed that a standard UTI culture would cover everything that could cause a UTI. And I've since learned that's just not the case.
Today, Eliana is healthy and thriving, and her family is grateful.
Hello, I'm Dr. Crystal Eisenhower, CEO of Apiriomics. Apiriomics' mission is to advance healthcare by revolutionizing the way infection is identified. Now more than ever, the world is painfully aware of the negative impacts undiagnosed infection can have because of the economic and health impacts that COVID has caused on the entire globe. Apiriomics technology is able to identify every known bacterium, virus, parasite, and fungus in one test. This technology has many applications to NASA, including pre-screening astronauts before flight and studying our microbial footprint left in space. Our technology has been used for over 3 years to help patients all over the world, just like Eliana, get answers that no other test could provide. The problem at its root is that infections are simply not identified. This is because traditional testing is incapable of identifying the majority of microorganisms that can cause infection in humans. For example, standard laboratory cultures can identify only 10% of known microorganisms. Our technology, Explore Patho, allows identification of every known microorganism by looking at the genetic blueprint for each bacterium, virus, parasite, and fungus. So how does Explore Patho work? Explore Patho is better infection testing. The first part of what we do is wet lab sequencing. We start with a sample from the patient. That sample should be from the source of the infection. So if somebody has a chronic urinary tract issue, we want a urine sample. We work with many different types of samples, including blood, tissue, urine, fecal. We also do environmental testing and working with pharmaceutical companies, so this has broad applications beyond the clinical application we're focused on. We take these samples and pull the DNA out of them and test them for every known bacterium, virus, parasite, and fungus. And we do this using deep DNA sequencing. DNA sequencing technology has been used for cancer and genetic testing for several years, and we are now applying it to infection testing. This produces a very comprehensive, very complex data file that can be up to 1 terabyte of data for just one patient sample. The second piece of our technology is our dry lab analytics. This is the core of our technology. We are effectively a software company. The massive data file from a patient sample is analyzed through our algorithms, matched against our databases, and then our artificial intelligence is applied. The goal of our analytics is to generate a report that identifies and quantifies every known microorganism, as well as key information about the microorganisms to help healthcare providers understand how the sample is different from healthy. Beyond that, we also provide consultation services to the healthcare providers because we want to make sure that that healthcare provider has everything that they need to be able to understand the report that has every known microorganism, how much is there, and context about what kind of impact this may have on the patient. We oftentimes refer healthcare providers to other doctors that have similar patients, but also infectious disease pharmacists that can help those healthcare providers figure out what to do next if infection is indeed their diagnosis. The first portion is the software. These are dozens of modular algorithms that use a unique statistical strategy to identify the unique information in each sample. Next is our genome management system. This is a comprehensive, dynamic, and high-quality system that we've developed. It contains the complete genetic information for every known microorganism. Right now, this is nearly 40,000 microorganisms, again, every known bacterium, virus, parasite, and fungus. Within that 40,000 microorganisms, over 12,000 of them have been documented to cause disease in humans. To give some context, the Centers for Disease Control tracks about 350 microorganisms. We are the only company in the world that is tracking every known microorganism that causes disease in humans. The third piece is our machine learning, which is designed to put context around the microorganisms identified. But if we don't put context around that information to help them understand how this is different from healthy, then the doctor oftentimes doesn't know what to do with this information. Aperiomics began operations in 2014, and our mission is to advance healthcare and revolutionize infection testing. And we've built an amazing team. In addition to our highly experienced management team, we have technical, clinical, operations, and sales experts that are all committed to our mission. We also have strong advisory teams and an active board of directors. The market that we serve are healthcare providers that treat infection. This can be anyone from a nurse practitioner to an infectious disease physician and anyone in between. Putting a size on this market is very difficult. This not only includes things that we traditionally think of as infections, but also things that we're increasingly connecting to infections. Some of these are considered autoimmune conditions, some of these are considered chronic conditions. We do know that pathogens tracked by CDC result in about 200 million infections per year in the US. We know that this is an underestimate for all infection, but starting with this number and drilling down through our addressable market puts us at an annual US market of $39 billion at our out-of-pocket price of $789 per sample. Aperiomics is clearly set apart by the fact that we identify thousands more microbes than possible by any others. Our biggest competition are healthcare providers that never have a definitive test for infection. There are also labs that do infection testing. These use various technologies, including culture, which we've talked about, but also DNA-based technologies. These other DNA-based technologies can only identify a fraction of what we are able to identify through our technology. Our new paradigm for infection testing is already making an impact in how healthcare providers operate. Instead of running test after test, Aperiomics simply identifies everything known. We also provide context around the information so that the healthcare providers have the best possible information to come up with an appropriate plan for treating that patient. This paradigm shift has already allowed us to identify infection where all other testing has failed. One example is Mary. She is 58 years old and has suffered for 37 years with debilitating chronic bladder pain. She has had symptoms of a severe urinary tract infection for decades, but existing urine culture tests have been incapable of identifying the root cause of her infection. They've told her that she has a condition called interstitial cystitis, which is an autoimmune condition with no known cause and no known cure. This condition disproportionately impacts females and the elderly. Mary learned about our testing through a patient advocacy group and requested that her doctor order our urine test. We received her urine sample in our lab. We pulled the DNA out of that sample and then used deep DNA sequencing to analyze over 20 million fragments of DNA from that sample. From that data, we were able to identify a unique bacteria that is incapable of growing in urine culture. Based on our testing, her pain finally resolved. Our technology creates a true win-win scenario. Patients can finally get better or simply never become chronically ill in the first place. Healthcare providers can get these patients out of the revolving door of their practices, and insurance companies stand to save hundreds of thousands of dollars on cases such as Mary's. Or even better, prevent them from becoming these chronic cases that cost the healthcare system so much. And the beauty is that the quality of care was not sacrificed. We have made substantial progress in our 3.5 years on the clinical market. We've received substantial funding from the National Science Foundation through their Small Business Innovation Research Program. We have also worked with over 1,200 clinicians all over the world, helping thousands and thousands of patients. We have generated about $3.5 million in service revenues, most of which is from patients that are paying out of pocket because insurance hasn't provided broad coverage for what we're doing just yet. We've also raised capital from angel investors in the amount of $3 million. We're currently raising a Series A round and looking for syndicate partners. That said, our most notable accomplishment is that we recently received our first Medicare payment for our urine testing. This is a huge milestone for us and opens the door for broad insurance coverage, which will give better access to patients for our testing and help us achieve our mission. As Aperiomics moves forward, our vision is to become the gold standard for all infection testing. Becoming the gold standard means that patients developing chronic conditions will significantly decrease. Some examples include autoimmune conditions like interstitial cystitis, such as Mary's case. Neurological conditions such as Alzheimer's, some forms of autism, and depression are also linked to changes in the intestinal tract. Chronic conditions such as obesity, some forms of diabetes, and cardiovascular disease are also in this category. As we compile data from tens of thousands of patients, the use of big data tools and artificial intelligence will allow our technology to become predictive. An example might be going to your healthcare provider for your annual checkup, and they identify a bacteria that in the future we associate with increased risk of cardiovascular disease. So the healthcare provider gives you a prophylactic treatment for this bacteria to reduce your risk or potentially even eliminate your risk for developing this cardiovascular disease in the future. Remember, we are testing for nearly 40,000 microorganisms in each sample. This is far greater than any technology that NASA is using at this time. There are many applications to the space industry with our technology. There are medical applications and there are scientific applications. Imagine a world where astronauts can be pre-screened for infection before flight. This could reduce the risk of an individual astronaut developing an infection, but can also prevent others they work with from contracting an infection. What about a world where astronauts can be post-screened to study the effects of spaceflight on their health? What if an astronaut develops an infection in space? DNA sequencing can be deployed to space stations to identify infection in astronauts. Our technology can also be applied to countless scientific questions that have huge bearing on NASA. What happens to microorganisms at zero gravity? What impact do humans have on in-space environments? The human body contains 6 pounds of microorganisms. With every breath and every skin cell that sheds from our bodies, we are leaving behind a tiny trail of microorganisms everywhere we go. What impact might this have on new environments that we're creating in space? We can also help discover new microorganisms. What if microorganisms we carry into space mutate and evolve into new types of microorganisms that have negative impacts on humans or environments in space? Or what if we find life on other planets? This technology could be used to help unravel those mysteries. Aperiomics is poised to disrupt healthcare. To achieve this mission, we need additional resources. The first is to secure additional funding. As I mentioned, we are running a Series A financing round now and looking for syndicate partners. We also need to perform broad marketing and education. We need to help healthcare providers, patients, and insurance companies understand the true value of what we're doing. Given the fact that our technology is a paradigm shift, the amount of marketing and education is significant. We also need to secure additional insurance coverages. As I mentioned, Medicare has provided their first payment for our urine testing, and that's a huge first step. But there's a lot of work to do in order to get additional insurance companies to follow suit with Medicare and provide additional coverages for our testing. This will give patients better access to our technology as well as help achieve our mission of getting this technology into broad use. With your support, Aperiomics can achieve our mission to advance healthcare and revolutionize infection testing and improve human and astronaut health. Thank you.
All right, thank you. We'll open up for questions.
This is Dallas.
Go ahead.
This is Dallas. I have a couple of questions. Can your test identify COVID-19 today? How fast is your testing process? And can you identify unknown DNA sequences?
So we are able to identify COVID today. Had we been testing the samples that were originally in China before the pandemic began, our system would have called SARS, which would have been slightly incorrect, but it would have been a major red flag. So our technology has huge implications for being able to get in front of something like the pandemic we're experiencing now. Our testing takes right now, we can run it in as fast as 3 days. But right now, our standard turnaround time, because we have to batch samples together to keep the cost down, runs between 7 and 14 days. And then what was your last question?
To identify unknown DNA sequences, new diseases or new pathogens.
Yes. So we have when we analyze the DNA, it goes into different categories, and one of those categories is called unclassified, and that includes everything that doesn't match to something that's known. We can go into that information and do de novo assembly and align it to things that it's most closely related to. So yes, we do have that capability, and we're going to be building some new tools around that.
Thank you.
Julian?
Great. Yeah. No, it's a great segue to my question. And based on what Dallas was saying is, what is your data source? Are you do you have your own proprietary data source, or you're kind of licensing data from other entities?
So we pull data from various public sources. When scientists discover something and they sequence it, they publish those sequences online publicly. Now, that is not a quality controlled system, and it's also not peer reviewed. So we've had to build an infrastructure that will quality control all of these genetic sequences so that we only include things in our system that are validated and are what they say they are. So just an example of exactly how dirty the system is, there are over 100,000 microorganisms that have been sequenced. We include nearly 40,000 in our system because a lot of what's been published by researchers is not of suitable quality for clinical use.
I have a quick question for you. How resilient is your diagnostics to sequencing errors?
So we use Illumina platforms, Illumina DNA sequencing platforms, and they have the lowest error rate that sequencing platforms can have. There are also some built-in correction systems that Illumina uses to prevent those sequencing errors. So I don't have a hard number of what our error rate is, but it is as low as it can possibly be with this technology.
Hi, so this is Rick Stockberger. So use of these proceeds is going to go into a lot of education, it sounds like. Can you dig a little bit deeper on what that education process looks like and what you feel like the best forms of education are for your customers?
Yes, so a lot of that will be in the form of trade shows, and actually we have one coming up in just a couple of weeks, the Infectious Disease Society of America's ID Week. So we have a booth, we have posters a poster that we're presenting at that event. So getting in front of large groups of people to help educate them on the value of what we're doing. So that's one of the biggest ways, but also peer-reviewed publications, which we have several in the works, going and doing speaking engagements. PR has been a really, really big thing. The Today Show piece that we had at the beginning of our segment, that was an amazing opportunity. And If you ever want to crash a website, get on the Today Show.
Great, thank you.
May I ask another? Yeah, may I ask another question? So your business model is to identify what we call in medicine occult infections. In a sense, aren't you kind of cannibalizing yourself by solving a problem? And therefore, especially when some of these occult infections, are kind of a one-time event. I understand if it's a patient with chronic disease like interstitial cystitis, but oftentimes it's an occult infection, and if you solve it, then you're limited in terms of your true market. Could you touch on that a little?
Well, yes. So I don't see this as cannibalizing ourselves. People get sick many times in their lives. We all have infection after infection after infection, sometimes with the same exact things over and over again. So what we're doing is we're trying to get in front of this process where instead of the healthcare provider making an educated guess or using answers from existing laboratory tests that are incomplete, if not inaccurate, and preventing people from getting into these chronic phases, but also the predictive ability of what we'll be able to do when big data becomes part of this is huge. Being able to predict where this is a regular part of the annual screening process. So I don't really see us cannibalizing our own business, but really creating new opportunities as the technology matures.
John Carr.
Yeah, hey, this is John. Can you help me understand the size of the wet lab portion? Are we talking about 700, square foot lab or something the size of a 3D printer?
So our laboratory is about 2,000 square feet total, and there's plenty of extra space in there. So this could be, the footprint of this could be fairly small. And I know that there has been DNA sequencing performed in space. So this certainly could be applied in very small confined spaces.
Ben, you had a question?
Hey, Crystal. This is Ben Lockman. Can you talk a little bit more about your competitors and what else is out there that's kind of in your space? What differentiates you guys from other people that are out there? Thanks.
Sure. So one of the most notable competitors is a company called Carr. They do DNA sequencing, but only from blood. We work with virtually any type of a sample, including non-human. There's all kinds of non-human applications here. They only identify about 1,500 microorganisms. We're approaching 40,000. And they only work in a hospital setting. We work with any healthcare provider that is legally able to order a laboratory test. So they are looking at a very defined, segmented part of the market, and we're a much more broad application. So that's probably the closest competitor. There's some other software tools that are similar. There's a lot of advantages. We've benchmarked against everything we can, and we outcompete all of those software tools. Most of those tools come out of academic settings. Ours did, however, we had to go through some substantial work to create something that was suitable for use in a human.
Sherman, you had a question?
Yes. How you doing, Crystal? Really excited to talk to you. I've been covering down on life science tools and diagnostics for about 8 years now. So very passionate about this space. So the first question is, do you either have the ability now or are you developing in the future to send kits to labs, or are you just focused on having your own central lab? That's my first question.
Sure. So we actually don't want to be a lab at all. We have a lab and we do the wet lab piece because we needed to create the market and create the access to that sequencing. How we scale is we teach other people how to do the wet lab part. That is special know-how. It's very complicated and requires a lot of sophisticated personnel and equipment. Our business is software. So eventually this will be a software as a service where we can distribute this far and wide. And our outlook will be through acquisition. My perfect scenario would be Illumina acquiring us and embedding the system into their instrument, so you have a sample in, answer out application. Oh, I can't hear you.
You mentioned that you at the very end there. First, you said folks are paying out of pocket, I think $750. And then you said something along the lines of you just got some sort of reimbursement. What was the CPT code? And if it wasn't that, then did you get it from like a payer provider? Like, how did that work?
Yes, so we actually have had some out-of-network insurance coverage with several private payers for the last 2 years. So Blue Cross, United, and Cigna provide out-of-network coverage. We have 5 codes that we stack together because there's different parts from sample collection to processing to data analysis. So there's multiple codes that get stacked from the private insurance standpoint. With Medicare, you can only bill 1 code, and so you have to go through a process to get a Z code. I don't know the Z code off the top of my head, but we have one. We're a Medicare provider, and we were able to get that through Medicare. We're in the process now of validating the Medicare payment process and getting our framework in place to do a formal launch of our CLIN patho urine testing. That will be, we're looking at a November launch for that right now.
All right, we have time for 2 more questions.
This is Dallas. I'm going to jump back in. How do you get tested by Aperion Onyx?
The only thing you need to do is have a supportive healthcare provider. And if you don't have one, we have worked with over 1,200 doctors all over the world. We may have one either near you or one that does remote care. So really, it's just a matter of talking to your healthcare provider and determining if infection is something that makes sense from the symptoms and looking at blood work and such. And then we work with the doctor to make sure the right samples collected at the right time.
Would any provider know of your company?
Not yet. We have a lot of providers that know about us, but that's part of the next phase of this. Getting that insurance piece in place was really necessary before we go and start broadly educating the healthcare providers, because most healthcare providers are going to be hesitant to recommend their patient pay $800 for a lab test.
So the patient would have to know of you and bring it to the doctor's attention.
Yes, and that's how we have operated for 3.5 years. We've generated over about $3.5 million almost exclusively from patients finding us online and taking us to their doctor.
Okay, final question.
Hey, Crystal, this is Peter Hughes from Goddard. Great presentation, great product, exciting position. I can't wait to discuss it with you at the impact table, some applications for new life detection as we explore the outer planetary system. So well done, great job. Can't wait to talk to you guys.
Thank you, it was a pleasure.
Can I ask one quick question? So can you talk about any penetration with payer providers or potentially penetration with the VA or DOD?
We haven't tried to get into the VA or DOD yet, because our primary focus has been educating patients and proving that there's a market and that people will pay for this and that it's clinically valuable. So we haven't made that next step, but that's certainly a great use of this. Mental health is being increasingly connected to gut health, and we can do that in a way that could potentially be a profound impact on the veterans specifically.
All right, thank you, Crystal. Max, back to you.
Thanks, Crystal. Can't wait to see some more discussion on that in the impact tables. Great talk. We're going to go on now to Autolith Labs and Sam Owen.
I'd like you to meet Claire. She's a research audiologist who developed a vestibular disorder called Meniere's disease. When she gives a lecture, her tinnitus is so loud she has to ask the front row if she's speaking too loud or soft. And every morning, she has to sit in bed for 45 minutes waiting for her vertigo to subside before she can walk safely. Claire's story is typical for those living with vertigo. 70% miss work and nearly 6% have to leave their job because of it. Claire isn't alone either. In the US, 16 million people develop vertigo every year. This results in 4.4 million visits to emergency care centers. Vertigo creates over $10 billion in medical costs from emergency care visits alone. But the kicker to all this is no existing standard of care for vertigo exists. Put simply, an ER doctor would rather see a broken bone than a vertigo patient because at least they'd know they can make it better. One prominent ER doctor put it this way: if there was a fast-acting solution for vertigo, it would be revolutionary, not evolutionary.
My name is Sam Owen. I'm the founder of Otolith Labs, and I'm going to tell you about something revolutionary.
Vertigo is primarily a symptom of a condition related to the vestibular system. The vestibular system is essentially a motion sensor that's inside your inner ear. What Otolith has developed is a small bone conduction system about the size of 8 quarters stacked that sends an inaudible vibration to stimulate the vestibular system in a constant but non-informative way. Think of it like a white noise machine. For instance, if you're laying in bed trying to sleep, but noise from traffic, dogs barking, or people talking is keeping you up, you can turn on a fan. That fan produces a white noise that allows you to naturally tune out those disruptive sounds and lets you sleep. Now, to be clear, your ears still work fine. Your brain has simply de-emphasized the sensory input because it's constant and non-informative. That's exactly what Otolith technology does, but for the vestibular system. And it works incredibly well at managing vertigo. We've been able to attract interest from multiple researchers hoping to try our technology on their patients, including doctors from Jefferson University, the University of Maryland, and the University of Miami. These studies, along with our own internal studies, have had amazing results. Here's some of the feedback that we've received.
I felt the dizziness start to creep back. Just popped it on again and was fine seconds later.
I don't like being without it. I'm wearing it every day. It's given me the ability to drive again.
I've been using the Otolith device and have found significant relief to the extent that I've been able to return to work.
Frankly, it was hard to send it back, but I did. My vertigo was considerably better.
I have one patient right now that is suffering from vestibular migraines. The device has been a huge game changer for her.
And how fast does it work?
Instantly, it's like flicking a switch.
Immediate, long-lasting relief without side effects that has a meaningful impact on people's lives. That's what we're developing here at Otolith. Today, our technology is reliable, robust, and designed for clinical trials. But by the end of next year, we plan to have a consumer-ready design which we'll submit along with our clinical data for FDA approval. In the future, our compact technology could be integrated with headphones, hats, and more inconspicuous wearables. It could communicate with other sensors and wearables as part of a smart device platform and come on automatically as needed. And in the future, we could offer a low-cost device with electronic refill to make the technology more widely affordable.
But Otolith technology has users beyond just those with debilitating vertigo.
Motion sickness is also vestibular related. For instance, if you're reading in a car, your eyes say that you're stationary, but your inner ear says that you're moving. This causes a sensory mismatch, which results in spatial discordance. Your brain, sensing something is off, believes that you have ingested a poison, and you end up with nausea. Now, unlike vertigo, there are options for motion sickness. However, regardless of whether it's Dramamine or those wristbands, they all try to address the symptom of nausea. Otolith intervenes much earlier in the process by addressing the vestibular system and preventing the spatial discordance. It is the only solution that prevents the cause, not just the symptoms. The result is it works immediately, lasts indefinitely, and because it's just white noise, has no side effects or impact on vestibular function. The benefits go beyond car sickness. The same spatial discordance is behind air sickness, seasickness, virtual reality sickness, and of course, space sickness. You may recognize Bob and Doug, our astronauts who recently returned from space. Here they are describing what they expect to happen.
I'm expecting a little bit of vomiting maybe to happen in the end game. So when we get to that opportunity to do that in the water together, it's kind of a weird thing to say, but I'm looking for that kind of celebratory event.
Motion sickness takes place at every step of space travel. From the costly inability to work when first arriving in space to the dangers of severe motion sickness during a water landing. Motion sickness is such a big problem for NASA, they actually have a written Human Research Roadmap Gap SM27 searching for a new, non-pharmaceutical intervention for motion sickness to reduce astronaut dependence on drugs and avoid their harmful side effects.
Well, here it is. And you know what? NASA isn't alone.
The U.S. Air Force recently awarded Otolith with a $1.5 million Phase 2 SBIR to integrate our technology into pilot trainee helmets for the AETC. The goal being less trainee dropout due to motion sickness, which accounts for over $1 million in sunk costs for every trainee. And the Defense Health Agency is looking for a portable vestibular stimulator to reduce vertigo due to vestibular dysfunction, which occurs in 1/4 of Iraq and Afghanistan war veterans. Well, I couldn't describe what we're doing any better than that, which is why we were awarded a $250,000 Phase 1 SBIR and have submitted a proposal for the Phase 2. Of course, motion sickness prevention has commercial applications as well. Car companies are all gearing up for the introduction of self-driving vehicles. The problem, of course, is a lot of people don't want to be a passenger when they get motion sick, and nobody wants to pop a pill for a 20-minute ride when it leaves them drowsy for the rest of the day. Well, we can help here too. Both Jaguar Land Rover and Ford have conducted placebo-controlled studies on our technology and found that those with our technology lasted significantly longer and developed significantly less motion sickness symptoms when wearing our device as compared to wearing a placebo device or when they wore no device. And VR Motion, a small business and military contractor that develops driver training simulators using virtual reality, saw their dropout rate plummet from 20 to 30% to below 1% when they began using our technology in their demonstrations. Clearly, we have a technology that can be applied to multiple markets. There's the medical market, which is by far the largest market in terms of dollars spent, poses the least competition, and addresses the biggest pain point. We are building ourselves as a standalone company, but have begun reaching out to larger players in the ENT space to consider potential partnerships or acquisition. There's the military market, which has provided us with early revenue and demonstrates market need. Additionally, custom military integrations could preserve the price point of a medical device while providing significant revenue in the long run through sole source contracts. There's the automotive market, which has demonstrated efficacy of our technology through free clinical studies and may draw interest from their venture groups. And finally, there's the VR market, which is fast growing but has significant adoption issues due to motion sickness. Our technology can be easily integrated with VR headsets, and because it will be part of a larger system without medical claims, we won't even need to wait for the FDA approval for it to be sold with the VR systems. Now, being a small company, it's crucial that we stay focused, which is why for now, we are focusing on the medical market because of its size and pain point, and the military market to provide us with early R&D funding. Our market path will start with going through the FDA. Since our technology is the first of its kind, we'll go through the de novo process as the first fast-acting treatment for the management of vertigo. We anticipate submitting to the FDA in early 2022. This path will ensure that we receive a unique HCPCS code, which will result in significantly higher reimbursement rates down the road than devices which simply manage nausea. Of course, reimbursement will take some time, and we imagine our first users will need to pay for our device out of pocket. We've identified ENT offices as the best initial market entry point, as ENT doctors already have the existing infrastructure to sell their patients hearing aids out of pocket. Will simply be another product that they can offer their patients at a similar price point. So let's talk about market size. It's huge. The emergency departments see 4.4 million patients a year for vertigo, and there are 16 million incidences a year just in the US. With even minor penetration of the market, Otolith technology could result in over $1.6 billion in revenue. Now, before we get there, we're looking at the DoD and other government agencies for early revenue. So far, we've received $1.8 million in government contracts. Looking forward, this year we're in the process of applying for or awaiting on feedback from over $4 million in additional funding. As a company, we're focused on answering two basic questions. Does it work, and will people buy it? For motion sickness, the first question has already been answered. Yes, absolutely. But we currently have a telemedicine study enrolling along with our university studies to answer this for vertigo. The data so far has pointed towards yes, helping the majority of people with vertigo. We plan to take what we learned from these pilot studies and apply them to a pivotal study starting next year in anticipation of our FDA submission in early 2022. Regarding will people buy it, we're of course receiving market validation from the military, but more importantly, our telemedicine study currently underway has demonstrated how desperate these people are for anything based on the number of signups we've received even before we started advertising. We may also test a limited market release in a foreign market to further understand price point once we have an FDA-ready device. Of course, we'll need funding to do all this, which is why we plan to raise our Series A beginning this fall and continuing into winter to take us through FDA approval, and plan to raise our Series B to fund our launch into the US market. Now, no medical device deck would be complete without an IP slide, and we've been awarded 2 strong method and utility patents. First, in order to create the vibration we needed within an inch of the ear, we had to develop what is quite possibly the world's quietest vibrator, while simultaneously being as powerful as a vibrator nearly 15 times as massive. But more importantly, we were able to quantitatively define the power and frequency levels of the vibration needed. Even if someone can invent another quiet vibrator, they can't do what we're doing without being a placebo, being dangerous, or infringing on our patents. We have a strong technical team that includes inner ear experts who have spent 25 years at the University of Maryland School of Medicine, product designers who have brought over 20 hardware products to market, and a couple of business development gurus who spent the last 20 years working with startups after leaving their executive positions at AOL. As a company snapshot, we've been awarded $1.8 million in government contracts, and we've been able to raise $2.4 million from angel investors. And these aren't just friends, families, and fools. Our investors include the founders of K2M, which was recently purchased by Stryker for $1.4 billion, the founders of Harpoon Medical, and 4 ENTs who have seen the effect of our technology on their patients. At the beginning of September, we had $621,000 in cash, and we're cash neutral through November as we execute on our awarded contracts. What we're looking for now are medical device investors to speak with as we prepare for our Series A round. We anticipate raising $10 to $15 million, which will fund the company through FDA approval. We're also looking for introductions to medical device companies in the ENT space, especially if it's a company that missed the now saturated hearing aid market and doesn't want to miss the next big thing in otolaryngology, such as Fuji or Olympus. Also, we're looking for introductions at the highest levels of VR companies or Facebook. I hear Sheryl Sandberg, the COO of Facebook, gets VR sickness. While we are trying to stay focused on medical, if there is the opportunity to quickly monetize a non-core market like VR through licensing or partial acquisition, and simultaneously solve one of the VR industry's biggest problems, we'd like to speak with someone who can make decisions. Finally, as I mentioned, we are currently enrolling subjects in a telemedicine study to further investigate the efficacy of our technology on vertigo. If you know someone who has frequent attacks, please forward our information along to them. And if they're not able to participate in this one, we anticipate having several follow-on studies, and we'll always reach out to those in our database first. So in summary, Otolith has developed the first therapeutic to treat a large, unaddressed market. Our technology has been proven effective and has a low-risk profile. We have an experienced team that can bring a product to market, and most importantly, we address a written NASA technology gap. Immediate, long-lasting relief without any side effects. Let me show you what that looks like.
And then instantly, and I feel like I can actually have some intelligibility in speech. That is really, it's amazing.
All right, thank you. Let's open it up for questions. Sherman, go ahead.
Hey, how are you doing? Do you plan on getting 510K or going after 510K or PMA?
Yeah, so we will have to do the de novo 510K. So we have to create the classification, and then we'll go through the 510K route. We'll be a class 2 medical device.
Raja, how many people do you think you need in your trial? Have you gotten a clinical trial specialist yet or no?
Yeah, so we're working with a clinical trial specialist who's helping us get through the FDA. For motion sickness, the power study showed around 100 people being necessary in the pivotal trial. The improvement we're seeing in vertigo will probably indicate that it's going to be about the same. Given its low-risk nature, a lot of the things aren't. It probably won't have to be especially, huge or anything like that.
All right, thank you, Ramona.
Yes. Do you need to wear this on both sides of your head, or a single side is sufficient?
So we had started a study before COVID to look at both sides, but single side seems to work. We want to answer that question of does applying it on both sides make a difference? Unfortunately, that study got shut down due to COVID. But what I can say is the level of vibration that we use is low enough that the skull essentially looks like a single object and it penetrates both sides of it. So there may be improvement, but it's not necessary.
And I just want to share an observation. Imagine, just wondering if you folks have thought about this. In some concepts, this seems similar, once again, only conceptual because it's electrical versus yours is vibration, to a TENS unit, a transcutaneous electrical nerve stimulation device, which I've had notable experience using. Have you ever talked about or the similarities and how that works in disrupting signals? Everything's taking place normally, but the pain in a TENS unit or the vestibular disturbance is gone.
You know, I've got my chief science officer on here. He probably knows more about what's in the literature. Didier, you want to answer this?
Yes, so our device is much more unobtrusive than a TENS device. It is just vibrations. You don't need any gel or anything for application. This being said, it's something that I would like to do. It's compare TENS to our device and measure the efficacy. I just wanted to add just one thing about unilateral versus bilateral. We have done a study on cadavers by having optical fibers placed in the inner ear of several cadavers, and we find that at the frequencies that we use, which are very, very specific, the skull acts as a single body. And so, at least from the cadaver point of view, it doesn't seem like unilateral versus bilateral matters much.
Okay, thank you.
Any other questions?
Yeah, I have a quick question. Is it the device does everybody need the same frequency, or does the frequency vary by person? And so, for instance, if you put this in a car, would it be just a device that anybody in the car could use, or would it be that it need to be tuned to a patient?
So first answer is frequency is not important. So that was one of the graphs that I showed in our IP slide, is that if you have the right power level, frequency is not that important. However, frequency is important for safety. So if it's too low, you can actually feel the distractive tappings. If you go too high, you actually risk hearing loss. So at the frequency we picked, it's essentially inaudible. But if you go too high in frequency, you could actually cause hearing damage. For power, which is really the question that you're getting at, is it one size fits all? We have a very large range that's in our IP. We have found that depending on the vestibular disorder, there is some variability. However, with healthy vestibular systems, with motion sickness, you can have essentially a one size fits all. You could add in variability just for personal comfort, but essentially it's one size fits all for motion sickness.
So this is Dallas. As someone who woke up with severe vertigo, in my opinion, out of the blue, this device sounds like something that would really have quickly dissipated the process of healing. It took 3 to 4 months to get rid of it. Is that a true assessment?
No, it's not. So we are symptom management and only symptom management. When you put on our device, it masks the vestibular system and it relieves the symptom of vertigo. It does not address the underlying cause. It does not help you heal faster. It is completely symptom management. However, if you just need to get back to work, if you need to go from severe vertigo to moderate vertigo so that you can now walk and do stuff, that is what our technology does.
I could not walk. I could not get out of bed. Basically, I was falling off the floor. So this would solve that problem. It would not solve the healing process.
That's right. It would probably still take the same amount of time for you to heal, but if you needed a fast act, it's like taking a Tylenol. Tylenol is not going to solve the root cause of the pain, but you know what? The pain's gone. You can now function.
That's great.
Hey, Sam. Rich Godwin here. Nice to see you again.
Good seeing you.
One of the things I was wondering about in terms of the space program and with NASA's requirements is that space sickness is not always, it's mainly caused by motion, but it's not always caused by motion. Sometimes it's caused by spatial disconnect, where you're going from one room to another where you think you're on the ceiling and then all of a sudden you're on the other side of the ceiling and you think that should be the floor, and then you look around and your brain suddenly goes, whoa. So your eyes are telling your vestibular system something is seriously wrong here. Is that still part and parcel of what your device can fix because of that?
Yeah, I mean, so if you remember the slide that I had that kind of showed the process of what causes motion sickness, that we're not going after nausea, we're going after the spatial discordance, and that is what we solve. We have not tested in space yet, but the closest analogy we've heard when speaking with NASA scientists is that virtual reality is probably the most analogous because it's a visual induced spatial discordance rather than a vestibular stimulation spatial discordance. And with virtual reality, we're incredibly effective, even more so than car sickness.
All right. Any other questions?
One more question. Can you tell us about the form factor? Is this something you can miniaturize further?
Absolutely. So this size right here, so about the size of 8/4 stacked, right now is about the smallest we can get our technology. We do have a new design that we're working on that's incrementally smaller than this, but it can't get too much smaller than this. Right now, we built it into some relatively unattractive device, but it works. And this is for clinical trials. However, going forward, what we're planning on doing is kind of having a pod-like design. So you can imagine something like this. It can clip into a hat. It can clip into a headband. It can clip into, just about anything. And this could be a very versatile product that you just have aftermarket products that it goes into.
All right, we have time for...
I have a quick question for you, Sam. Great product. Really excited about this and the applications for NASA, of course, and defense. Do you see any roadblocks to be able to use this in space in zero-G, and also any challenges for your target defense or the pilot examples where they have a helmet, there's a lot of vibration and other noise and other distractions? What are the challenges for those two application areas?
Sure, I'll talk about the pilot one. So ambient vibration is great. So if you're in a quiet room with nothing, you will actually, hear a little bit, you'll feel it a little bit. But if you're in a car, for instance, that's driving, there's an ambient vibration, you do not notice it at all. And so it becomes incredibly undistracting. So that's actually a positive, having all those good things. The issue that we ran into with the helmet integration is not an insurmountable one, but right now our technology is completely inaudible. The moment, well, I don't have one on me, but the moment you put it in an ear cup or you've now put it inside a resonator, you suddenly introduce sound again. So we're trying to work out how can we keep this, inaudible. But that's about it. With space, the big issue is power consumption. This little battery right here lasts for 18 hours. It works on less than 1/10 of a watt. So low voltage, low power consumption. It's incredibly efficient.
Excellent. Thank you, Sam. Looking forward to talking to you guys later.
Looking forward to it as well.
We have time for a couple more questions.
This is Dallas again. How long are you taking applicants for your clinical trials?
So the current trial is a 40-person study, and we have 30 through it already. That being said, this is a pilot study. We are using this to inform our pivotal study, which will launch next year, and we plan to do it through a telemedicine way, just because all of our clinical studies at these universities have all been shut down because it's no longer essential. So we will be taking people for the next year at least.
And there are online applications at your website?
Yeah. If you go to just otolith.com or otolithlabs.com, you can find it. Again, if you can't get in with this particular study because it's going to close relatively soon, We're going to pull from people who are in our database first and just say, hey, if you still have this problem, we launched a new study. Would you like to join?
Thank you.
You had in one of your slides that you were looking at chemotherapy. Can you explain how that works for your device?
Sorry, what was the question one more time?
You on one of your slides, you said you had funding from NIH on chemotherapy, and I thought that was a chemical-induced nausea, so I wondered how your device works on that.
Didier, you want to take this one?
Yeah. So this is a bit of a mystery as to why it would work. It was, it's going to involve 5-HT receptors that are involved in the vomiting associated with chemotherapy, but it would take me half an hour to present the sort of hypothesis we have as to why it works. What we do know is that our device was used in 4 people at Drexel University Oncology before it shut down. And all 4 patients had vomited so much during the first round of chemo, cisplatin, that they had to be readmitted for rehydration and care, which delayed their second round of chemo. And so during the second round of chemo, all 4 patients wore the device, and only 1 patient threw up only once. And so we had a promising start until, unfortunately, Hahnemann and Drexel got sold and shut down part of their operations.
Does it work? Would it work for morning sickness?
I've been hesitating on that because once you get into a pregnancy and things, liability insurance might be a little too high for us. So I would like to know the answer to that. There's only so much we can do, and we have to choose.
And I do want to just add briefly, so in our study, we have enrolled some people who have medication-induced vertigo, and our technology has worked incredibly well.
Real quick question, what about motion sickness?
So motion sickness works incredibly well. That was the first thing that we tested because it's so easy to induce. And
we had an independent study conducted that has been published by Jaguar Land Rover. It was conducted independently of us. And another study, which is not published yet, but was also very positive, conducted also independently of us by Ford. The only thing we did was just to provide them with the devices and instruction for use.
Excellent.
Right.
Thank you.
Last question, Kurt.
Couple of real quick questions. First, have you looked at intermittent use of this instead of continuous use as a power saving approach? If you want to have your battery last longer than I forgot how long you said, but does intermittent application work?
At this point, not so much. We haven't done enough studies on this. What we have seen anecdotally is basically you put it on, you turn it on, and there's an immediate reduction in symptoms. You turn it off, symptoms come back. There's some evidence, especially with motion sickness, that if you acclimate to kind of if you get used to tuning out your vestibular system, say if you've worn it for a couple of hours, you can turn it off and you don't immediately start paying attention to your vestibular system again. There does seem to be some lasting effect if you've had it on for a substantially long time, but eventually it does come back. But all that being said, it's less than 1/10 of a watt. It doesn't take much to keep it going. A single AA battery would essentially last for 20 hours.
Okay, thank you for that. And quick additional question. Are you looking into incorporating that into like sound canceling headphones? Because it seems like, like what I'm wearing might sort of make the whole thing easier to do. I just wondered if you've looked into that.
100%. It's in our patents. That's the obvious integration thing. It's just a much harder integration, product design. So we're going to start with something simple and then expand into accessories.
Okay, thank you.
All right, thank you. That ends the Q&A. Max, back to you.
Yeah, I was really excited about that one. I told them in some of the pre-work that I was excited to see if they could rename the NASA's vomit comet. As somebody who's been on there a couple of times, I see that there's a lot of misery that goes on that plane. So if you guys can help out some NASA engineers, maybe not even in space, but while they're doing some testing. I'm sure you'll have some happy customers. Now we are going to move on to Tivasol, who's going to talk about a little bit about some potential organ-saving technology.
Hi, my name is Julian Agendron, and I am the co-founder and chief medical officer of Tivasol Transplant Technologies. Did you know that 4 people die every minute from end-stage heart and lung disease? That means over the course of this brief 15-minute presentation, 60 Americans will die from end-stage organ failure. That's right, end-stage organ failure is an extremely common problem, and though we have thousands of people waiting for organ transplantation, millions of people die annually from end-stage organ failure. So why don't we transplant more people? Well, the reason is because less than 1 in 1,000 people who die become an organ donor, and as a result, very few organs are available. Having said that, even fewer actually go on to become used for transplantation. In fact, of the precious few organs offered, we waste over 75% of these organs, saying they're unusable for transplantation, leading to lives lost. And that also comes at a huge cost. The cost of lung disease in 2020, just for chronic obstructive pulmonary disease, will be $49 billion. And the cost of heart disease treatment of indirect and direct costs are close to $219 billion in 2019. This is a massive burden on society. And yet, there is a multi-billion-dollar industry waiting should we be able to have an effective treatment of end-stage organ disease. If we grow these organs in a lab, if they're bioprinted on a 3D scaffold, or if they come from a cryopreservation form by being frozen, or even xenogenic models that lead to organs being formed in another being for transplantation, these all need an opportunity for assessment before quality is deemed appropriate for transplantation. Of course, we're well aware of the current lives we live in this pandemic, which is why we're virtual here today. And unfortunately, there are many more patients with severe lung disease from COVID-19, even several months after clearing the infection. I want to highlight the sad story of Myra Ramirez, a healthy 28-year-old woman from Chicago who was admitted to hospital back in April with COVID-19. Her disease was intractable to her lungs, and on June 5th, she went on to receive a double lung transplant. And you don't need to be a physician to appreciate how destroyed that lung tissue is. Thankfully, she did return home at the end of July, though now a patient post-lung transplantation. And this is what healthy lungs are supposed to look like. And this is my donor team that has gone out recently to procure a healthy set of donor organs for us. But the reason we don't use many organs at all is because transplantation is done just like this. We pour a cold solution over these precious gifts of life, hoping that this cold time that lasts for about 8 hours will be enough for us to transport these organs wherever they need to go. And then in an unsophisticated way, we take those precious gifts of life, put them in the same cooler that you might take to the beach for a long weekend, and then race them around the continent. Finally, they come to my operating room. It's a privilege to be presenting today. And as you can see, these lungs have traveled the distance to get to our room here while they're still cold and still on ice. And what we're going to have to do is get these lungs flowing blood again back in my patient. And as you can see, these lungs right now are pretty white. There's no blood in them. And they're actually slowly dying as we're doing this right now. So I want to say a special hello to my favorite Chief Technology Officer, Dr. Harry Partridge, who told me he missed all of his biology learnings afterwards to avoid these things. So I hope this is not too gory for you. But what we're going to do now is start dissecting these lungs apart. This is the cuff of the left atrium. That's going to connect back to the heart. This is the pulmonary artery. That's going to connect back to the heart that brings the blood out of the heart. And we're going to sew these in. So I think the next thing we're going to show you guys is once these lungs are inside the chest and ready to be flowing with blood again, what they're supposed to look like. All right, stay tuned. Okay, that should be good for now. All right, so we're just sewing up the end of the pulmonary artery here. And with that, we would have completed the major anastomoses for this lung transplant to allow for these lungs to start to breathe again. And so we're going to take off the clamps now. You can see the silver clamp behind the artery I'm sewing. And we're going to purposely have a little bit of blood come out because we want to de-air it a little bit. And then hopefully the sewing has worked. And we're going to then allow these new lungs to breathe in their new chest. We'll just take one more here. So let's cut and take this, and then we'll allow these lungs to breathe again. Okay, guys. That's the good old heart in the middle. It's been kind of battered around from side to side while we do this transplant. And you can see the lungs moving up and down, and slowly that natural pink color coming back into them after the long journey, and like I said, slowly dying throughout that journey. But these look like good lungs, and I think we're going to have a good result. So thank you guys, and I'll take you back to our presentation. All right, great. And due to all of those uncertainties is why we created EVOS, the ex vivo organ support system by Tivasol. It allows us to have the exact same form factor of the ice cooler, being compact. It also allows those organs to breathe normally with blood flowing through them at a physiologic manner. And this is done at normal body temperature. This can be done for over 24 hours compared to the 8 hours of the ice cooler, allowing for extended preservation. And during that period of time, we can evaluate these organs to make further decisions about their quality. We can even intervene specifically to repair these organs. Of course, our technology is portable and can go anywhere, which allows for equitable sharing of organs, even to areas that right now are underserved. So how can we improve these organs? Well, if those organs are full of pneumonia, we can treat them with antibiotics. And by treating them with antibiotics, we're able to get to a viable, usable set of lungs. If those organs are too far away, let's say in Hawaii, we can fly them over with the EVOS device and bring them back to the mainland, where they can be transplanted. And during that time in transit, they actually become better quality organs. If the lungs are wet and boggy, full of fluid during a resuscitation of a donor, those organs can be dried out safely to a normal weight where they can function normally again. And even if they're full of blood clots, those organs can be actually treated on our device with clot-busting drugs to lead to a safe and workable set of organs usable in transplantation. And we've done exactly that. In fact, we've performed a first-in-human clinical trial using our prototype device you see on the right, using 12 sets of organs that were going to be discarded, and all 12 sets were converted into viable donor lungs, and all 12 sets were successfully transplanted. And you see patients numbers 1, 5, and 7 all alive and happy over a year post-transplantation, when many of them would not have received a gift of life at all. This has been acknowledged by the highest level of peer review, with our manuscript now in press at Nature Communications. It has also led to us developing a strong patent portfolio for our company with 48 filed patents of 6 patent families. Our business model is simple. We use the disposable sets that touch every single organ and that is where our revenue is mainly generated at a price of $21,000 per set of disposables. And then there's a service contract for the actual base unit that we charge the hospitals or the payer. And this is minuscule compared to the current price of double lung transplants, which is over $1.6 million. So anything that would improve the quality and quantity of viable donor organs is highly sought after by patients, physicians, and hospitals. Indeed, there is a large opportunity for cost savings as well. Better logistics allows for better matching of organs at better times. This means that operations will happen during the day with well-rested surgeons, which is known to improve outcomes. We won't be spending overtime costs on nursing and anesthesia as much. We would minimize the cancellation of elective surgical slates because we do operations during the night that cancels them. There would be better quality organs from minimal cold ischemia times, which has many significant cost savings, including less time on the ventilator because the organs are functioning better, less time in the ICU because the patients are recovering faster, less time in hospital as they convalesce post-ICU, and less rejection due to better matching. And that leads to less infection as well, due to improved immunosuppressive regimes. This would lead to less readmissions to hospital from complications post-double lung transplantation, which is another major cost to the system. Overall, there are enormous opportunities for savings far beyond the cost of the devices and equipment. We're doing this with a fabulous team. Myself and Dr. Freed are the founders. We're both trained internationally in cardiothoracic transplant surgery with a bright team of engineers and management surrounding us. We've hit many major milestones in our first 5 years since inception, including development of a first-in-human clinical trial and the beta prototype that we have available today. We move over the next 2 years into our pivotal clinical trials and plan a launch of the device in 2022. We've done all of this up until the clinical trial with less than $5 million US, which is a fraction compared to others developing medical devices. Tivasol is excited to announce a $10 million strategic investment last week, which aids to secure our commercial pathway. The opportunity financially is large. With the appropriate assumptions of 80% market penetrance over 5 years, an increase in transplant volumes by 200% over 5 years, and a growth in transplant wait list of 40% over 5 years, we could have annual sales of close to $400 million over that period of time. So why would NASA be interested in Tivasol? Well, our lab is the only lab in the world that is capable of ex vivo preparations of hearts, lungs, livers, kidneys, and now even limbs. And this is a short video taken nearly 6 years ago now from our lab. And what is NASA doing that is of interest? They are trying to grow 3D tissue in space for the purpose of transplantation here on Earth. And to do that, they're going to need our portable devices that are a stable platform for tissue regeneration. Those organs fabricated in space can be tested for physiologic function on our devices. And finally, those synthesized organs can be transported back to Earth for transplantation on our platforms. Even for the lofty goal of deep space travel, NASA would find use of our technologies. Current strategies for induction of torpor and moderate hyperthermia include porcine models that are to be progressed to astronauts. We can mitigate the risk to astronauts by examining the planned pharmacological therapies in isolated organs to determine toxicity for prolonged exposures. And finally, with our technology at Tivasol, we're able to test pharmacological agents on isolated organs at zero gravity rather than performing small clinical trials on astronauts as a first step to mitigate risk. In conclusion, I would like to thank you and know that Tivasol is a company that looks to partner with NASA for our technology and our personnel who have much to offer the future. Thank you.
All right, thank you. Let's open up questions. Ramona.
Does it require different setup for the different organs? Will the one EVOS work for all of those 5 or 6 organs that you mentioned?
Thank you for the question. The form factor of the external components of it, the hardware, would be quite similar, being compact and portable. The internal components, however, would be specific to the organs that they're perfusing and preserving.
So you would perhaps, when you sell these, you'd have a more kidney-based system versus a lung-based system, or to be more fine-tuned to the particular organ?
That is correct.
Okay. I look forward to discussing with you during the impact tables about using it with our astronauts later. I'll let others ask questions now.
As a follow-on to that, would you have a single external kit with insertable devices per organ? So you'd have a lab or an inventory of internal kits?
Potentially, that could be developed because the external form factor would be strive to be similar. However, it's different technology for different organs. For example, the heart technology that's being developed as we speak uses 2 pumps rather than the single pump. So there'd be a lot of differences between the organs, though the form factor overall and footprint would be similar.
Okay, Sherman.
Yes, very, very impressed with what you're doing. It's really exciting. A couple of questions. Do you have the ability to deliver cell or gene therapy? Have you thought about that from a terrestrial application? Because it's cell and gene therapy manufacturing, with space manufacturing is one of the most difficult things. And then actually getting that product to the patient is a problem. So have you thought about that at all?
Yes, absolutely. And early on in the introduction, when I talked about the multi-billion-dollar industry that could be developed, printing of organs by definition requires infusion of cell and gene-based therapy. And so those bioscaffolds, for them to be populated to allow for a actual organ, physiologically functional organ to be developed, certainly requires that platform for instrumentation and for delivery system. And beyond that, our platform then allows for actual testing to determine if functionality is accordance to what they attempted to do with gene therapy.
All right, Julian.
Yeah, fascinating technology, Jan. A couple questions. One is, how long have you tested, or do you have an idea of how long you're able to kind of have this kind of prolonged cold ischemia time and still have kind of viable organ? That's my first question.
Yes, thank you, Julian. And I'll just clarify that the time that we have on the device, we don't consider cold ischemia. We're keeping those organs at 37.4 degrees Celsius, just like it would be inside of you and I right now. So we call that normal thermic preservation. And we've kept human organs alive for over 2 days with that technology. And we've not transplanted them. That's been in the lab so far, but we believe we can go further than 2 days as well. With what we use right now with the ice bucket that I showed you during the presentation, we really start to have irreversible damage to those lungs after about 6 to 8 hours. So we're in a very tight window as we work today.
That's incredible. My second question is the slide where you talk about the your market penetration. You're making an assumption of 80% market penetration, which seems a little generous, but there are only so few hospitals capable of doing these types of organ transplantations. And do you imagine that these hospitals will buy multiple devices, or one device and would use it multiple times? What are your can you talk about your assumptions here?
So we believe that each hospital would probably require 2 or 3 devices because they may be dealing with more than one donor at a time, as is very common at our large transplant centers, including our own. But as I said in the presentation, the revenue is generated mainly from the disposables, which is a one-time use per organ preserved.
Okay,
This is
next
Dallas
question.
again. You talked of your 12 tests where you implanted 12 pair of lungs, and you mentioned 3 survivors after a year. What happened with the other 9? If you can share that at a top level.
I apologize if that didn't come through clearly. All 12 survived to 1 year, 100% of them. There's only 3 in the picture. The other 2 people in the picture was myself and Dr. Freed, the other co-founder. So I apologize if that didn't come through. It wouldn't have been accepted at Nature Communications if those were the results.
Yeah, thanks for the clarification. That makes me feel better.
All right, Ben, you have a question?
Yeah. Quick question as far as on-orbit, tissue generation and transport there and back. What's your estimate for like up mass requirement? How big is this thing and how much does it weigh?
So maybe I'll defer to our Chief Scientific Officer and co-founder, Dr. Freed, to talk about the form factor and weights.
Sure. Darren Freed here, co-founder of Tivasol. Pleased to meet you all. So the form factor essentially is equivalent to the current ice cooler that we use. So you saw the picture in the presentation of the Coleman cooler that the lungs were going into. A priority for us was to not upset the current workflow of transplant programs, particularly on the donation side and organ retrieval, et cetera. So what we did is we basically made our device, we squished it down to the size of an ice cooler. And roughly the same weight. So it weighs about 40 pounds. And then that external dimension, like I say.
Dr. Freed, Rich Godwin here. I'm looking at some experiments being done on the ISS in the next few years that are going to be growing tissue and potentially, advanced architecture of tissue samples. Could you explain a little bit more about how your device would be able to do to be utilized on orbit and also for transportation back down to the ground, because the transportation is always a big issue for us.
Sure. So the portability aspect of this has been a key element for us. As mentioned, portability is not only an issue for going to space, but also when you're trying to transport multiple organs around the countryside. So what we've done essentially is to take the form factor down to something that could be managed by a single person, ideally. Perhaps easier to manage with 2 people, just like your cooler generally is. And within it is the entire functionality required to maintain a pair of lungs or a heart or a liver or a kidney in a warm, perfused, fully functional state. Now, I guess for the application for NASA, one could potentially look at other scenarios where the organs are cooled to a moderate degree, say to room temperature, which would then obviously significantly change the power budget for the device, since you no longer have to warm it to normal body temperature of 37 degrees. And you may not need to have a fully functional organ at normal body temperature simply for the purposes of transportation. So that's another variable that would be relatively straightforward to build into the system, being able to modulate the temperature to such a degree.
I have one recommendation as well, is if you don't already know them, I'd be talking to TechShop about your technology, because they might be able to help you in a big way when it comes to space applications.
Right. Okay. Thank you for that.
Any other questions?
Yes, I have another one. Do you have any Internet of Things components to your product? So how things are performing on the inside of the box can be beamed via Wi-Fi or near field communication outside. I care about that. I care about also tracking of the device as it's in transit. Can you speak to any IoT components?
Sure. We actually did our prototyping on IoT devices that you would commonly be able to acquire through standard electronics, sort of the suppliers. In that vein, we've actually taken that forward into our production device, where the user interface is essentially on a tablet that the user can hold. So, for example, they could be sitting in the front of the ambulance or the taxi, as the case may be, or the airplane, helicopter, spacecraft, and the organs themselves are back in a storage hold, and the user could be interacting with them through that tablet interface, wireless interface, so that you could not only be monitoring the condition of the organs, but also intervening, changing parameters, et cetera, on the fly during transport. Within our jurisdiction, where we have long transport times, it was my philosophy when we started this technology that we might as well take advantage of that transport time to intervene on the organs and get them functioning better. In terms of the data acquisition, data warehousing, data analytics, et cetera, that is another key component that we're interested in, because as we develop this further, it is very likely that we will be able to identify novel metrics of organ function or predictability of post-transplant function that we currently don't have access to in an intact donor. Whereas if you separate the organs from the donor and you're intensively monitoring all of these data points, we may be able to generate novel endpoints that we can use to predict post-transplant function. So that data warehousing, data capture, et cetera, is critical for us as well. Not only from that perspective, but also from helping the end user troubleshoot if they're having difficulties with a set of organs, having access to that data in a real-time sort of manner. So that's a significant component of what we're doing from a software perspective.
All right, we have time for one more question.
Go ahead.
Go ahead, Harry. I've already asked.
You said that you can keep hearts alive for 2 days. I wondered if you can speculate on how far you think you could push this. Is it possible to go a week? Is it possible to go a month?
So I was talking specifically about lungs at first, Dr. Partridge. Hearts potentially could go for that period of time as well, with maybe varying the conditions by which they're preserved. Keeping them currently at normal body temperature, they certainly can be extended out much longer than our ice cooler can have hearts in them, because with the ice cooler, hearts are very sensitive, and even after 4 hours, there's damage. But in terms of the projections for how far we can go, that will really come with collaborations in other areas of industry with interest in hibernation and developing techniques to allow for longer periods of storage. Ultimately, the platform will allow for us to deliver that organ and then test it to show that it's functional at the time that it's to be used. So whatever happens in between, and whoever the partners are that want to intervene on that organ to allow for that extension of period, including maybe even developing immunosuppressive regimes specific to the potential recipient, are possibilities. But our device will show you if that organ is able to work at the end of all of that as well.
If I could just quickly add to that, there was a group at the University of Zurich who just recently showed that they can keep a liver, human or porcine livers, alive outside the body for a week on their device. So the whole idea of moving towards essentially organ banking. So right now we have a blood bank that has revolutionized how we do transfusion medicine. The idea of having an organ bank, I think, is something that we need to be thinking towards as a transplantation community, where you can schedule the transplants based on the organs you have available in your bank. That's not that far off.
I have one comment. Wow.
Thank you, sir.
Thank you.
All right. That will conclude the question and answers. Max?
Yeah, I will reiterate the wow, not only for Tivasol, for all of the innovators who just spoke. It was really an impressive set of videos, an impressive set of Q&A, some amazing companies, technologies, some amazing people. And I am not a judge, and I am happy for that. That is excellent news for me. So you guys are going to have your work cut out for you in trying to figure out a winner. I wanted to mention we do. If anybody who's watching the live stream today, if you guys like what you see and you'd like to contact us for any number of reasons, maybe you're interested in doing being a participating company in a future NASA iTech event, or maybe you're an investor who likes what you see and wants to talk to one of the companies you've seen, or wants to be a judge or a participant in a future event, please give us contact us at the nasaitech.org contact page. We'll be happy to try to make connections or try to bring you in as a participant, a judge, investor, entrepreneur, observer, whatever role you'd like to have. We'd be happy to make contact with you. I want to reiterate my thank yous to all the participants today, the judges, the companies. Everybody did a phenomenal job. I'm really proud to be a part of the program that you guys put on today. And I invite everybody, especially everybody on the live stream, to come back and rejoin us tomorrow at 9 a.m. Eastern Time, where we will start off. We will start with the second half of our program. That will include the presentations from Skyrora, Neuroflow, Orbitless Drives, and Mojo Vision. And I think they're going to be just as impressive as the ones we saw today. And I hope to see you all there. Thank you.